Hello and welcome or welcome back to our afternoon part of the Gerd Kretschmer Memorial Symposium. I'm very happy to be able to welcome our next speaker. The next speaker is going to be Daniele Nardi from Sapienza University di Roma. He has been there since 2000 and is being active research-wise in the area of AI and robotics. So he is actually leading the cognitive robots teams, and the topics which he has been covering in this working group are actually very rich, and they reach from cognition for robots over localization, navigation, and perception to multi-robot systems, human-robot interface, multimodal interfaces, and spoken dialogue systems. He has been also very active in very many EU projects and also frameworks like FP7, H2020, and has been a RoboCup president from 2011 to 2014. So he's going to give a talk about quantitatively evaluation of semantic knowledge about robot environments. So Daniele, now it's your stage for half an hour.
Okay, thank you very much.
Kein Ton.
Thanks for the introduction. Very nice. I could not really miss this occasion of joining these people and friends to remember Gerard, to have good memories about him. I decided to take a more technical presentation, which connects quite well with the previous talk by Michael Bitz, because it's about semantic mapping. He showed in his lecture a remarkable system creating maps of shops in a very nice and effective way. However, also for Michael, the problem of quantitatively evaluating how much knowledge and how accurate knowledge his system was able to acquire is still a problem. And this, I think, this idea connects very well with the effort on benchmarking that also together with Gerard, we have done along the years. Okay, let me move on to my presentation. So first of all, I deliberately put the wording semantic knowledge in the presentation, in the title of the presentation, because it's a wording that I find not really, well, somewhat odd, because how can knowledge be other than semantic? I think it's by definition semantic. And in fact, the word semantic has been abused in many contexts, starting from semantic knowledge to, maybe even semantic robots. So we are really talking about this common sense understanding that robots need to have about the environment in order to accomplish interesting things, intelligent things in the environment. So which robots? Service robots in particular. In fact, here you see several examples. One I want to mention explicitly is the Roomba, because the latest versions of the Roomba do have a semantic map, because they understand about environments and they know what is a kitchen, what is a corridor, and so on and so forth, which is maybe not much in terms of knowledge, but it's still relevant to the task that the Roomba is doing. Plus, I want to mention that recently on the IEEE Spectrum, an article by the engineers at iRobot was pointing out that the software of this service robot, I'm sure you're all familiar with this cleaning robot. That's definitely a service robot. Is going to change dramatically in the sense that it will start becoming more collaborative with the human, as opposed to being fully autonomous in the cleaning. So the human has to specify what to clean, how to clean, and so on and so forth. And from this point of view, it cannot do it without a semantic map of the environment it's working in. This brings several societal opportunities for leveraging the performance of robots in the elderly care, patient care, child care, you name it. But I also want to point out that semantic knowledge or semantic map will be useful also for other categories of robots. Here are two examples. Here is if you want to give a command like bring to a industrial robot, bring me the screwdriver on platform 2, the robot needs to understand what the screwdriver is and which one is platform 2 and which place is platform 2. And similarly, in a search and rescue environment, the knowledge about the environment itself, as it is shown in this picture, which I steal from the Sherpa project, again by Michael Bitz, shows that understanding the environment is not important only from a geometrical standpoint, but it's also quite important from the point of view of the semantic features of the environment itself. Now, what is semantic mapping more precisely? I think that this is a great definition. It's not a definition actually of semantic mapping. It's maybe been attributed to symbol grounding, and it's by a novel writer, well-known, Saramago, and it says something which is very relevant to us, and I still thank Alessandro Saffiotti for pointing out this quote, which is, for things to exist, there are two essential conditions: that a man should see them and be able to give them a name. And this is, to a large extent, what semantic mapping does. We need to be able to associate object representation with names and with the knowledge associated with the object themselves. More, let's say, formally or closer to us, Erzberg and Nuchter define semantic mapping, in addition to spatial information, the ability to assign mapped feature to entities of known classes. I would more generally speak about knowledge in the environment, but this is the starting point. And what are the semantic maps for? They are for they help to performing reasoning and very much communicate with humans. Any sort of spatial referring expression, like please clean the Coke spilled near the stove in the kitchen. This is something that can be very reasonably assigned to a cleaning robot, and it refers to the environment and to the objects in the environment they're in, using natural language. And in order to do so, a semantic map of the environment is a must. Now, again, more formally, for a semantic map, like for a map, you have to have a reference system, but the information about the environment is divided up into two components. A component which is called M in this representation, and it's about geometrical elements in the environment itself. And then there is another component called P, which is more about the symbolic knowledge about the environment itself. This can be articulated in many ways. The basis may be given by the instance of relationship, which is telling us that an object belongs to a class. And then eventually the hierarchical relationships among classes, which is whose basis is the is-A relationship. And it's important to combine these two elements into a single representation in order to leverage the performance of robots. So here, the 3D point could be an example of a geometrical representation, and here is an example of a hierarchy. Now, one point in common when you talk about semantics is that when you have a reference to an ontology, this reference should be common, because ontologies, the need for common ontologies has been highlighted by the semantic web, and here is the same thing. Unless we are able to refer to the same ontology, it's very difficult to compare the knowledge, to match the knowledge, and therefore, in order to do a performance evaluation, a reference is needed. It doesn't really matter which one in particular, but a reference is needed in order to be able to make very precise statements about how much semantic knowledge has been acquired by a robot. Without this common knowledge, common reference, I think it's impossible to talk about comparative evaluations. More concretely, semantic mapping amounts to, can be characterized by several different aspects. We have been talking about labeling rooms or labeling objects, naming attributing a type to the rooms or a category to objects. And this is addressed in the literature in different ways with different approaches. And there is a large literature on this, and there are also references that you can find and surveys that provide a very good view of the work done so far. But there is also an interactive approach, which is sometimes referred as a human-augmented mapping, where the robot is talking to the user in order to acquire knowledge about the environment. And learning about doors, it's one example. Through the interaction with the user, the robot can learn that the door is an exit door, as opposed to other type of door, or maybe an emergency door. And all this information may be useful in the operation of the robot. And of course, this paradigm opens itself to many other ways of enriching the knowledge of the robot. Now, this is probably the attendees that that were at my talk, which was mentioned by Paul in Bonn. Remember that I was talking about this topic, at least to some extent, also in that occasion. And this is the last part where I recall something that was said there. We have developed an approach to semantic mapping by use of a pointer and by use of interaction with the user in order to create a very rich representation, because in this way, there is no need to have a classifier that is capable of detecting all sorts of objects, and you can also label objects that are unique or that are specific of a given environment. So the idea here was to provide very rich knowledge and very specific knowledge about a given environment, rather than being able to classify every kind of objects of a certain category. Anyways, I'm not going to say more about this. On the interactive approach, we have done some more work, which was about reducing the number of steps in dialogue with the user in order to build this semantic map. Anyways, I want to move now on towards the main topic of the talk, which is the evaluation of semantic mapping. As I mentioned already, there are no standard references, and I think all of the approaches proposed so far, they don't have any benchmark, maybe with the exception of the approaches that consider semantic mapping simply as the problem of labeling pixels in 2D images or 3D point clouds. There is much more to that in semantic mapping, as I will show later. In any case, that's the only type of benchmark. I will go back to various ways that have been attempted in order to evaluate these systems. But there is no standard approach, except for with the exceptions that I mentioned. So there is a real need for doing some evaluation and some benchmarking. I already pointed out that there are cases where there are benchmarks, but they tackle only a part of the problem. Mostly the evaluation is qualitative. Sometimes there is also the user studies are used in order to provide some sort of evaluation. And user studies actually tend to be more about the form of interaction rather than the actual result in terms of task achievement in map construction. And in general, all these remarks came out when we tried to justify the performance of the system that I mentioned earlier and I implemented in the face of the objections of the reviewers that there was no quantitative evaluation of this of the performance of our system. Anyways, from these ideas, it came up, why don't we do it with competitions? And as you can imagine, this involved also discussions with Gerard, starting with RoboCup, but mostly in Rocking. So we have been doing an attempt of doing this evaluation through competition. And in particular, this idea started with RoboCup, where the environment needs to be known. But in fact, there was nothing specific to the evaluation of the ability of the robot to create a semantic map, which is a concept that is being developed in Rocking. And then I will talk about the evaluation in simulation, which is the last achievement in our research. So as I mentioned, this idea of using competition to evaluate semantic mapping was fully developed in Rocking. The idea was the following. We want to provide the robots some environment and try to compare the semantic representation that they could build with some ground truth of the arena, which actually was where the robot was performing. This within a given limited time, and then be able to compare the output of this process with the ground truth. That's the key point. You know, how well is a team performing in comparison with the ground truth? And we want this evaluation to be independent from the semantic mapping and the method and the representation used. So here comes the task called Getting to Know My Home, which was one of the tasks that were developed in Rocking. The idea was that we would let the team acquire a map offline, the conventional geometric map. And then, of course, we cannot provide a completely new environment for every team. And therefore, we decided to rely on changes in the environment. And therefore, we wanted to the teams to report about the changes of a door, of pieces of furniture and objects. And then we wanted to test the ability of the robot to use the knowledge by executing commands that include spatial referring expressions, namely expressions that refers to the object included in the map. So in the end, we had come up with a very concrete way of doing this evaluation. So the teams had to deliver a semantic map file of the environment, including the objects in the doors, pieces of furniture, and their location, including possibly position and properties of other objects. And each object should have, was accompanied also by pictures and other representations. And everything was delivered in terms of metric map files for a ROS format. Now, this was a discussion that the getting to know my home that took place with Gerard. And I remember very well the first day when we discussed this issue, and Luca, Yoki, and myself were proposing this approach or some ideas because we did not have a procedure yet. And Gerard was against. Definitely, he didn't see the point. Why should we do this? And why? And then after 3 days, he comes up with this description that I reported here, which was exactly intended to prepare the stage for including the semantic mapping task, which he contributed. So it's been mentioned also in previous talks that Gerard's attitude in discussions was that he wants to have the last word all the time. But in fact, he was really a person that I would accept other people's view, and maybe after a couple of days recognize and buy them, and also further develop them. So this Granny Annie character was created by him, and this was used for the 3 years of Rockin as the flag of our competition. And as I said, this maybe is maybe a bit personal because of this remembering of this particular discussion, but it was also very influential in the running of the project. So what did we learn from this experience trying to evaluate semantic mapping? The setup is very challenging. It's very difficult to hide the changes, and there are differences, the changes in the environment, and there are differences in the performance of the teams that start as compared with the performance of teams that come later. And after all, the goal of achieving a quantitative evaluation was only partially achieved because we had very few runs, and there were many other aspects that were contributing to the overall system, overall evaluation of the task on semantic mapping. And moreover, the full process was still not suitably covered. Anyways, here you have a reference on this. There is also a link to a YouTube video, which I will not be showing due to the short time. And also a reference to what I think it's maybe one of the last papers that we shared with Gerard. Now I'm going to move on to the last part of this presentation, where I want to point out that semantic mapping is the first thing, that semantic mapping is not just the analysis of a set of 2D or 3D images, but it's a process which involves navigation in the environment, exploration of the environment, and the ability to gather information, to build these 3D maps based on possibly multiple views taken of the same objects or of the same environment. So our idea was to consider this approach in its complexity, including also the action part. And again, doing this in such a way that a performance could be quantitatively evaluated. So these objectives led us to build a system that in simulation allows to do this, the quantitative evaluations that we are aiming for, and to make a real comparison of really of approaches to the overall semantic mapping task. So a little bit more in detail, the full system that covers semantic mapping includes action and perception, plus a manager of the information, the knowledge that goes into the map, because one of the most critical operations is for the map is to keep consistency in multiple visits and multiple views of the same object and so on and so forth. So it's a non-trivial component of the overall performance of the system. It's not a one-shot extraction of information from one single representation of the environment. And moreover, in the action part, we have not only, we have exploration, and this became clear to me also for, at some point, also for, say, conventional mapping or geometrical mapping, because I saw that I noticed my friend and colleague Giorgio Grisetti going with a special care in moving the sensor in the environment so that in the end the system would be able to reconstruct a proper representation, because the limitation of the sensors were all embedded in its knowledge and its capability of acquiring data that afterwards the system would have been able to process. Maybe with the advancing in sensing devices, this is changed, but it's still one key point. So let me skip this thing and go to the description of the system. We have developed a simulation system in Gazebo. And with this simulation environment, we can repeat the semantic mapping process multiple times. We can create multiple environments, and we can replace individual components in the overall process of semantic mapping to see, for example, how important is the exploration strategy in the result of the mapping process. And this you see in the pictures, you see the standard Gazebo interface, and on the right, one of the environments that is seen from the top that we have developed for testing our ideas. And also we wanted to embed in our system for semantic mapping also the notion of active vision. Active vision is a process that moves the sensor in order to gather multiple views of the same objects, and in order to have to improve the quality and the completeness of the reconstruction. So typically this is based on an approach which is called the next best view, which means that the algorithm computes a position that the sensor should take in order to get the next view of the object that is going to be used for the reconstruction. This next best view is calculated by taking into account the center of mass of the object, and it moves circularly around the object, and typically the next best view is chosen based on information gain. Now the point is the following: suppose you look at the car, and you look at the car and consider the section of the car that you see, which is given the limitations of the sensors, either you are far away or else you see only a portion of the car. So if you apply active vision by taking the center, using the information that you have acquired about the object, you probably turn out finding the next best view in a position that is not coherent with the actual size of the object. So in any case, we have developed a first approach which was based on active vision, exactly according to this paradigm, and then a second approach where, in addition to this active vision, which selects the next best view, we have developed an approach where the system uses knowledge about the object in order to understand, based on the size of the object, what's the next best view in a different way. And in particular, this takes place by calculating the center of the object in a different way, and therefore moving the geometry in such a way that the system can actually reason about the size of the object and determine the best position for the next view. So we have these two approaches that we have called the AVA and SAVA, where S stands for semantics. And then we have done some evaluation through our system. And in fact, not only we did evaluate our two approaches, but we evaluated also the a method based simply on the exploration done by users. So we have 4 systems to compare, our 2 approaches plus the standard frontier-based approach, plus the user driving the robot for the exploration. Here is the example of the environments. We had 5 environments. We had multiple runs of the environments. And here is one example on how to make the comparison. We consider the object reconstruction index and the object number index. The first one is purely geometrical and refers to the number of voxels that are associated to an object. And the second one is, say, purely symbolic because it's about the number of objects. Of course, these two are only 2 examples of performance evaluation metrics that one could apply. And in fact, this systematic evaluation allowed us to come up with a number of findings, which I summarize here. In simple environment with small number of objects, there is not much difference among the methods, but in more structured scenarios, both AVA and SAVA are faster. And this is more relevant when the number of objects increases. And in various types of environment, the superior performance of this more informed methods for semantic mapping is clearly demonstrated. And in particular, in rich environments with many objects, the semantics really makes a difference. And in particular, the information about the size of the object can really lead to a better performance of the system. I am at the conclusion. To summarize, semantic mapping is I think it's a key feature for intelligent robots that we will see in the coming years. And I am a supporter of the interaction and also in the construction of the semantic map. And I think that this trend of collaborative system is going to become more and more available in the systems. And this performance evaluation is still a challenge. I think we have provided a good step forward with this simulation environment, but definitely more work is needed to test on benchmarks for real robot and possibly to go back to competitions based on this particular challenge. And let me close. Unfortunately, this system anticipated me. I shared with Gerard many hours and many things professionally. Among other things, he has been vice president while I was president of RoboCup, and he really helped me a lot to sort out situations that were very difficult to handle. And I'm really grateful to him for all the collaboration we had and all the time we spent together on the technical side. But I would like to share with you this picture with Gerard because it's also talking about the non-technical part. Working together brought us to have also some time off work together. And I have to say that I really appreciated his company and staying with him. Thank you very much.
Yeah, thank you, actually, Daniele. I can only return this for this very nice and inspiring talk, as well as having this picture, of course, in front of us, having these nice and good memories, of course. Um, but I would like to ask you some questions, yeah, because at the very end you mention that the semantic aspect is something key for, yeah, let's say service robots or for intelligent robots in general. Yes, Daniele, I buy it. Yes, it is key. But it is also very complicated. From your talk, I think I have some deficits, yeah? Let's say but I think you gave a very nice example, and the very nice example which you get was the robot who likes to know his home. Get known to your home. And in this slide, you mentioned actually two aspects. You have something like a map base and some experiences which come on top of that. Yeah, so something you start out from ground truth, whatever this might be, and then you collect something on top of that. And if we make the example of a chair, let's say, yeah, so the robot is expecting and doing and trying to solve the task. I get to know my home. What will be the robot find, or what will be the reaction, what will the semantic content going on when the robot finds a chair which he knows potentially, because somewhere in its object storage he knows that there's a chair, but if this chair is sort of not longer at those places where it was expected. So what's the mechanism here? What is going on?
Well, that's that's a general problem of map updating, which comes no matter whether you consider geometrical information or you consider also semantic knowledge, as we have been mentioning. In fact, with semantic knowledge, I think you have an additional element. In fact, if you use only geometrical information, you have two options. Either you map the object, and then you find an inconsistency in the map and you have to resolve it, or you simply discard certain objects from your map. Actually, when you have a semantic knowledge about the object, you know that the chair is a movable object.
Right.
And then it's easier to reason about the fact that the chair may have been moved to another place, may even have disappeared from the environment. And that's all fine. And other objects cannot be moved. On a chair, a person can sit, and that's the kind of knowledge that I think can be leveraged in many ways on the robots.
Yeah, and you mentioned that you also had a system using this pointer type thing that you can actually make the robot learn this type of attributes, the semantic attributes, movability of a chair. You mentioned at the very beginning this system where you can actually point at objects and thus make the robot learn about its environment. This can be used. This can be used and this can be learned by the robot. Correct?
Yeah.
Yeah. Okay.
Yes, that's right. I did not insist on that system because I had presented it when I visited Bonn last time.
Yeah, I know. So I remember. Yeah, I remember.
So I thought it was not good to say the same thing.
No. New students, new audience. No worries, Daniele. No worries. Yeah, and this actually opens up another very nice aspect which you mentioned and which I like very much. And you pondered on active vision. Yeah, so you mentioned active vision as a very important aspect, and I think it's highly underrated. Yeah, because the reason is that we have, for example, all these image recognition, pattern recognition, object recognition algorithms. Yeah, so and of course they come from this other community of computer vision, perception, and so on. But all these benchmarks which we have there, they leave out the fact that our systems can actually do active vision, because there is actually no need for a robot to live with a single view on an object. Actually, a robot, as you pointed out, may very well be able to explore things, right? I mean, because if one view is not sufficient to make actually the semantic interpretation of this environment, he or she depending on the sex of the robot, can of course change the perspective and actually add actively new aspects to this knowledge gaining process, let's say. So have you an idea of how did you integrate this active vision type of thing into your architecture? How did you sort of benefit from this?
Well, actually, more in detail, the system works like this. Whenever it identifies an object in one of the images that is capturing while moving, then it stops and tries to map it. And the mapping requires to reason about the next best view. So this is how active vision comes into play. So the robot is supposed, in this case, just to solve the mapping tasks. So it's not building the representation while doing some other things. And this is, as I said, how active vision comes in. But in fact, it's if you do any experiment in a home and you are using, for example, one of these RGBD sensors, chip sensors, they have a very small angular view.
Right.
And therefore, if you are next, for example, to a closet, maybe the system detects that it's a closet, but it doesn't see it all. It only sees parts of it. And therefore, if it wants to build a good representation of the environment, it needs to move.
Right.
And that's why I've been insisting that semantic mapping is a process where motion and perception are really
intertwined,
very much connected to each other.
Yes. Okay, so let me check if there are any questions from the audience here in the hall. Well, this is seemingly not the case. So I like to thank you once again for your very interesting talk. I hope that we see each other again, maybe at 1700 if you can join. I'm not sure if you can join in the round table. Will you be able to join us there?
Yes, I will.
Great. So then actually we'll see each other again in actually something like maybe, well, 1.5 hours or something. No, 2.5 hours actually. So once again, Daniel, thank you very much. Now we have a little bit time left, which is 3 minutes still. We will close down the session here and we'll be back at 3 o'clock p.m. 1500 to welcome our next guest, who is going to be Manuela Veloso. Thank you for being with us and see you again in some time.
Thank you. Bye-bye. See you later.
See you later. Bye-bye now. an.
Hello.
Hello.
Hi.
Hi, Manuela. Thanks for being with us. Let me briefly introduce you before you start your talk, okay? Yes, so I really like to welcome now our next guest speaker, who is going to be Manuela Veloso. She is with the CMU University in Pittsburgh on the Herbert A. Simon Professorship and right now on leave to JP Morgan AI. She started her career in 1984 at the Instituto Superior Técnico in Lisboa, and then turned to the US, publishing her PhD thesis in 1992 at the CMU, which was very influential for the planning domain, for example. And then actually got an associate professorship in 1997, being full professor in 2002. All these positions have been taken at the Carnegie Mellon University, where she also actually educated 32 PhD students. Congratulations, this is a really huge number. She has been very, very active in lots of AI communities like ICHKA, AAAI. She's an HCM fellow and a AAAI fellow, and she's going to talk about today about AI in mobile robotics as well as AI in finance. Manuela, it's your stage for 45 minutes now. Thank you for being with us.
Thank you very much. So let me just share my screen. Just 1 minute here. Share. Okay. And slideshow. If we start. Okay. So thank you very much for having me here. I'm sure that we're all happy to be here, to be together, and with our broken hearts, because this is honoring Gerard, who I'm sure we all, at least I, miss a lot. So I'm going to talk a little bit about what Gerard somehow personally, I have not heard the other talks. I'm sure that everybody is mentioning a lot, but let me just tell you about this day. So I actually visited Gerard on June 29, 2017 in Ulm. And this was basically Gerard was recovering from initial treatments, and he baked this amazing strawberry tort for me because he knew that I loved this tort. And we had a fantastic time together that day. And we went into Ulm, and the reason why I share these also is because to see how much he was also, how do you say, trying to make me, he was loving me. I went there to be with him, to attend to him, and instead he baked the pie. He took me around in Ulm. He was showing me around, and I became very, how do you say, fond of the town of Ulm, as he was giving me this tour, showing me all these buildings, and being so, how do you say, so detailed. I really loved that day with him. And I finished with these initial thoughts with one picture, and I'll explain why this picture. So somehow he took me to this place where I stayed over. And the reason why I'm including this picture is not because of the background, not because of me, but because to think that he took this picture. And now I look at this picture and I can see him in front of me, and he's not in the picture. But how many pictures do we have? And I'm sure the family has, of pictures that he took. And so that's for me very moving, the fact that I have these pictures taken by Gerard. And I know he kept telling me, so make a smile and whatever. And I can see, and I will never forget this interaction with Gerard. That day we bought, we went shopping together. So interestingly, he helped me choose a dress. Not even my husband does that. So it was my husband is not as much into shopping. He helped me. I put on all these dresses. He said the ones I liked, the ones he didn't think so. And we ended up buying this dress, which I have in my closet here, and I precious it every time I put it on. For me, it's like a prayer for Gerard. And also we bought some sandals. I bought I wanted to give him something, so we bought these polos. We went to the store for men's clothing too. So he was telling me I like this one, I don't like this one. So we kept. So it was for me having after having known Gerard for literally 20 plus years, or that this was like such a, how can I say, such an act of love of him to give me a chance to know him along this personal dimension. And so I guess that's what I wanted to share with you, in some sense, that Gerald was very special and became, and through the years, very special to me. And I'm really sorry we didn't get a chance to, well, it was good that we saw him in Sydney and he was fine. And then it was very unfortunate to see how the plans of God, in fact, were different than our plans. So this is like how much I wanted to share of Gerard. I'm sure people have shared pictures of, and I'll also mention pictures of him at RoboCup. But so this is the beginning, and I'll be happy to also in the panel to brainstorm about more personal things with Gerard. We all know of his very long emails that I learned to read them by scanning them first, finding the main topics, and then going in depth. So I always read Gerard's email in a hierarchical way. There was always something powerful in his emails, the effort that he always had to reconcile things, to try to reach consensus. It was really a colleague from which I learned a lot of things, from not only technical, but also personal. So, I'm going to talk about a little bit RoboCup, about the research I've done. But, I also feel that I would love to be 45 minutes talking just about Gerard and how he touched my life, and how much we miss him. But let me just tell you a little bit about RoboCup one way or another, and then tell you about AI and robotics, what I've been doing. Let's see. I do tell you that I need to tell you that I had a little bit of a hard time picking the right selections of things to talk about, because, as I told you, I wanted this connection with Gerard, and so I'll be probably jumping around a few of the themes, but I hope that it gives you a feeling of what I'm doing, and then we'll go from there. So I'll show again, like, these pictures And look how happy we were, the two of us. And Gerard kept saying, "Put your camera further away, take a selfie." I say, "Hey, Gerard, I want to take a selfie. Move the camera." But and so we were like putting this camera back and forth to have this selfie, and it was really amazing. So, so let me just tell you, then jump a little bit into the technical content, and then I'll finish with some other thoughts later. So basically, the field of AI, as we know it, has been like about thinking about this connection between perception, uh, the reasoning, the cognition, and the action. And in that sense, as we embrace this particular kind of view of AI, autonomous robots are an amazing example of this. So I have this, and the reason why I have these ideas that I need to share with you that back in the 1989, I believe it was 1989, this thing about perception, cognition, and action that drives so much of my research was not well viewed as what AI was about, because people would work on AI in the 80s and from the beginnings on pockets of AI, like knowledge representation, planning, learning, natural language processing, speech recognition, machine vision. So it was a little bit, the field of AI was all fragmented. And in fact, just so we understand, there is nothing wrong with fragmenting the field of AI, because somehow AI is a discipline that needs to have a machine be intelligent, artificial intelligence, and definitely intelligence, human intelligence, has multiple facets. We can indeed understand language, we can understand images, we can make decisions. So it's really, the more I grow on the discipline, the more we realize that this concept of intelligence is multi features, multifaceted. So that was what the field looked like in the 80s. I mean, a lot of like fragmentation and, in depth, but fragmentation. And Alan Newell, who is this man here, which you can see the picture at the bottom, in the late 80s, one day, at Carnegie Mellon University, went to the board. And the reason why this is handwritten is because this is how I remember this blackboard. It was not blue, but it was black. And Alan Newell picked up this piece of chalk. We had this very fat chalk. And this was in an AI class. And he went, or an AI seminar, maybe. The room was packed with PhD students in those days. And then he basically picked up this piece of chalk and wrote on the board perception, cognition, and action. He actually made these boxes around these three things. And he said, this is what AI is all about, is to connect these things. And that's the term agent also was introduced in those days as this integration of this completeness of doing the three things, and not only delving into individual components, but trying to put them together. And when I heard this became, in fact, a lot of what drove my research, what drives my research 30 plus years, is to try to do this integration. I was just finishing my thesis on planning by then, or I was working on planning, but then on that component, that scientific component of planning. But then after I finished the thesis, I was all my research with my first student, Karen Haig, all the way to some of my current students, Anahita, there has always been about trying to understand these integration. Sorry for the long introduction, but I think it's important for us to see that. And therefore, when we had these RoboCup kind of like goal, in which autonomous robots, these teams of robots, but the team part was in fact beyond that concept of Alan Newell kind of integration, but it was these intelligent robots, these complete intelligent robots. And so I have been, the reason why I put these slides is that I think that I've been talking about intelligent robots always. So one way or another, it has always been the focus of my research, these complete physical intelligent agents being autonomous with sensing, cognition, and action. And this is a talk in 2001, but basically it was always what drove a lot of my research. And yes, I was quite younger then. So when RoboCup started, and here I'm going just to show this, just I'm sure maybe some other people already showed this, but let me tell you something that it's very important for us. Let me just see if I can stop this for a second. So think about these in the early 90s. And then there was around 94, 92, everything started in those early 90s. I mean, from some paper of Alan Mackworth to actually Minoru Asada trying to have these, reinforcement learning on a robot shooting into a goal. And all these things were like going on at the same time that the internet was also starting. But the internet, in some sense, all the emphasis was on these software agents, and not a lot of people in those days somehow remained in autonomous robots. Everybody kind of picked up their luggage, their research luggage, and moved to doing internet stuff, language, ontologies, distributed agents. I mean, it was all like at the beginning of the 90s. The reason why RoboCup was so important, it's because guess what? There was a group of people in the world who cared about mobile robots, and with this specific kind of long-term goal of trying to make them work as a team. So what I'm trying to tell you is like this: think about yourselves in those days before RoboCup, and in which indeed the emphasis was a lot on basically software, the internet. In fact, I remember when my first students coming to CMU after I became faculty in 92, in 93, I remember having a sign on my door, on my office door, when the new students would come that would say, so that had something, I forget the right words, but something that would say that I was interested in research in robots rather than on the internet per se, so that people would not come to talk with me if they wanted to do another like search engine or another like natural language processing. So because I was always, since I finished my thesis, obsessed with this thing of connecting perception, cognition, and action in mobile robots. So it just happened that also in 94, I believe Peter Stone joined as one of my PhD students, and he happened to love soccer. And we came across, actually, he came across a demo of these little one-on-one robot demo by Alan Mackworth in AAAI 94. And somehow that was the beginning of Carnegie Mellon, and then myself and then Carnegie Mellon engaging on this robot soccer. It was a phenomenal group of people, you know, from our Japanese colleagues all the way to, I don't know if I have a slide here with everybody, but look how it started. It's crazy that we started with, you know, these little, this is 98 already. But, you know, you had these small size, these middle-sized robots, you had like the small size robots, you had like the simulation, these 3 leagues being part of how RoboCup started. And basically we kept like aiming really high on what these would be. And then I think that here, I don't have any, I just have this. So, and so I just think that as I'm going to also focus a little bit on my own research outside of RoboCup, I assume that many people have talked about RoboCup. I want to, and you to understand one thing. So Gerhard joined RoboCup very early, I believe in 98. I'm not sure. I don't think he was in Nagoya 97, but my colleagues can correct me if I'm wrong. But I'm almost sure he was in Paris in 98. And again, like, you know, I have to tell you, I mean, there is something about RoboCup that it's still unknown to me, which is the passion for soccer itself. football, as they say. And Gerhard loved soccer. And in fact, uh, if um, if you all remember well, one of the things I remember the most also was in RoboCup 2016 in Leipzig, watching this World Cup together with Gerhard in our hotel, and I can see Gerhard, there watching. I forget which game we were watching. Some kind of game, probably Portugal against something or Germany against something. I don't know, but it was kind of like a must watching these World Cup games at RoboCup with Gerhard, and and it's still a mystery to me how he was so happy and so well in that RoboCup of 2016. And then a few months later, we got the news of these health problems. So I'm glad we got to have 2016 in Leipzig with him, and that was something that was a treat too. Maybe it was too much work for him. I don't know. I'm just glad that he got a chance to be with us and have us come to Germany for 2016. But the key for the success of RoboCup has been a lot about the community. In fact, a lot about having the symposium in terms of engineering, and these competitions as sharing of solutions, the dynamic setup, reachable, exciting, flexible, inclusive. So a lot of things that have been done well. And Gerhard is somewhere here in 2001, in which we took a picture of all the people and all the robots. So so I just want to share one thing about this, because Gerhard was so influential also in terms of the RoboCup, how do you say, leadership. So I'm sure that one day, that one day we will, even I believe, we'll be able to compile all the contributions of Gerhard to the organizational. But think about RoboCup as a structure that had our trustees, then the executive committee, and then technical committees, local organizing, regional committees, and all these teams. And Gerhard was extremely influential in the trustees group. I believe he was a trustee for many years. And then when I was president of RoboCup in 2008 through 2011, those 3 years, 9. So 2008 became president, but I helped with RoboCup 2009, 2010, and 2011. I introduced this concept of vice presidents to basically help with specific leagues and specific efforts. So vice president for junior, vice president for other leagues and other efforts. And I immediately selected Gerhard. And so Gerhard was my vice president for the 3 years. And if Gerhard is here, if Levent is here, if Changju is here, so especially also for 2009 in Austria, you cannot imagine, you all cannot imagine how amazing our organization was with, I was the president and Gerhard was there bringing this RoboCup to Graz, which is Austria. We kind of had not a very strong presence in Austria, but Gerhard was determined, and it was such an amazing choice. And then Gerhard, Daniele Nardi, Gerhard Steinberg, and myself, we kind of visited Graz, and it was amazing to see how Gerhard, all of this was due to Gerhard, the ability for him to help with a contract. So, we went there, the visit with everything, the organization, unbelievable man. And so my heart and my admiration for Gerhard even if I had known him till then, in my interactions in terms of being president of RoboCup and interacting with Gerard were amazing. And so I'm sure that you all remember 2010 also in Istanbul with Levant. Again, Gerard helped a lot, maybe not as much as with Gras. And then we had Singapore with Chengdu. Again, Gerard being part of a lot of RoboCup Initiative Junior, they are helping. So this structure is also was also kind of jointly designed one way or the other with Gerard, and that was the key for a lot of success of RoboCup. And just so you see, I don't recall which year this was, but here is like what these, how do you say, these RoboCup trustees meeting, this RoboCup organization was all about. Again, here, Gerard is here always. How do you say, extremely involved. We were all extremely involved. I think I'm standing there myself. I don't know who took the picture, but for sure someone who was also a trustee. But this was like what, this is how RoboCup is successful one way or another. We have the community for sure, but then we have this group of people who actually work so much together. And this is like the real feeling. It took me some time to find this picture. I knew I had it because it gives you a feeling for our interactions with Gerard. How were they? You know, we had papers that we wrote, we had screens with everything, we had laptops, we had water to drink, and it was always this interaction. And two of our trustees here now, Gerard passed away, but Silvia Corradecci also passed away. So it's kind of like, I don't know which year this was. Maybe this was 2009, but it was really remarkable. Okay, so let me go on and tell you a little bit also about Gerard and this RoboCup. Again, as you see, Gerard is there. I mean, you cannot imagine. This is, I believe, 2000 and when is this? 2008. This is RoboCup 2008, and you cannot imagine the influence that Gerard had on the actual RoboCup Junior, but not only an impact at the technical level, but an impact at the personal level. And it was amazing to see Gerard there in the award ceremony in many of the teams. And here is Gerard again, like with another team, applauding. He knew them, he loved them, and it was very nice to see him. And then another thing that I want just to focus, and it also took me some time to find this picture, is this picture here. And this picture is also in China. But so we had all that intense work, which was nice. We had also the competition and the awards and the junior and the senior and everything. And then we always had some social, some dinners, some kind of like ways for us to eventually relax, but also celebrate our work and our events and our the team, the community. So here is in 2008, is in China, these amazing dinners that they have organized for us, beautiful. I mean, and here is Gerard with, I believe this is Luis, and that's like Daniel and Itsuki, and here I don't know. And here he is telling his stories, and I was across from him in the table, but I could hear his strong voice and his stories, his jokes, his very respectful presentations to people. So this is like just I was searching for some pictures that maybe usually we don't share as much. There are no robots here. It's more about people, and that's very beautiful. So RoboCup from the beginning has been about these new, daring, challenging ideas. There are many scientific novel contributions, an amazing journey. But I wanted also to share with you this video, which basically is a testimony also from Herbert Simon. And Herb Simon is a Nobel Prize in economics, was a Nobel Prize in economics. And he was in the PhD thesis, my PhD thesis committee, not my advisor, but my PhD thesis committee, and also in the PhD thesis committee of Peter Stone and Astro Teller, actually. So, so I think that the way he talks about RoboCup, this particular video, even if you don't follow it closely now, I'll start it in a second. It has subtitles. It's available off my webpage, my CMU webpage. And I really think you should listen to this because it's this testimony to the robot soccer. So
here around CMU, we've been amazed, amused, gratified, and instructed in the last 3 or 4 years by the developments in robot soccer. I'm amazed we got through the session so far today, I think almost without mention of robot soccer. I think of it all the time, although I've been very slightly involved in the effort. For 4 years, and with rapidly increasing skill, computers have been playing a human game requiring skillful coordination of all the senses and motor capabilities of each player, as well as communication and coordination between players on each team and strategic responses to the moves of the opposite team. We've seen in the soccer games an entire social drama, played out with far less skill so far than human soccer, but with all the important components of the latter clearly available. And today, computer soccer seems to me to be sort of the quintessence of where artificial intelligence has arrived. There are other examples, as we heard this morning, but you just can see it all in one piece almost in the computer soccer. Interaction with the environment, social interaction, use of language. So it's a complex web of all the elements of intelligence and learning that artificial intelligence has been exploring for a half century, and a harbinger of its promise for continuing rapid development. Almost all of our hopes and concerns for the future can be examined in miniature in this setting, including our own role in relation to computers.
So, I mean, I don't realize I'm sure we all realize, and I really invite you to look at this conversation by this talk by Herb Simon. It is remarkable that he says that this robot soccer, in some sense, is it's like the eventually captures all these things we have worked on in AI, and it's true. In those days, we didn't even have yet the RoboCup at home, or we didn't have yet like the little humanoids, the now teams, and a lot of other interactions with humans and robots, and all sorts of these challenges. But it's very beautiful how he recognizes the impact of robot soccer as an AI platform. So let me just go back just to finish this RoboCup by just mentioning that this RoboCup future, we can be ambitious. And basically, if you think about these, we can have it be a unified for all robot soccer. We can produce usable by others data. This is a lot of the focus now of the trustees, is how to enable and encourage the community to really make the data that we collect, the data, the images of the field, the images of the robot, the decisions, the planning, everything, the history of a game, becoming data that we can use to learn and invent new algorithms. And we are trying to have 11 on 11 one day for inevitably mixed teams. And having some robot platform independent AI, and having a lot of these platforms for referees, for coaches, for anchors and commentators, for the summary generation, all automated. So all this infrastructure around the actual game playing also be automated. So these are, from my point of view, directions for the future of RoboCup in an ambitious way. And of course, also responding to audience feedback would be remarkable. So, RoboCup forms problem solvers, thinkers, and leaders. So you have to think that we embrace RoboCup as AI and robotics. And RoboCup is a taste of the old world for ethics, peace, good, innovation, transparency, happiness, kindness, empathy. So that's somehow how we view RoboCup. And I think that we need to understand that people have concerns about AI, about robots, about the future of how these technologies are going to be used. But somehow AI is a call to humanity to be responsible. Given that we invented it, then we better know how to use it. And this is Herb Simon kept saying also in that talk, that we are not spectators of the future, so we are actors of the future. So somehow through RoboCup also, we can help educate all our people, our community, on how to be good actors of the future. So finally, I want to finish, and I don't think I have time, I apologize, to go over the actual more of my research or my thoughts or my research on other robots and the financial world. I can mention it in the panel eventually. But you know, Kitano came up with these, by 2050, a team of soccer robots will defeat the World Cup champion human soccer team as one of the goals of RoboCup, and it's has been well cited, this goal. However, I do think that my version of this goal is that my revised version of this goal in 2020 and what I've seen for the future should be that by 2050, a soccer robot will be part of the World Cup champion soccer team. I'm not saying that we need to beat the humans, but that the humans and the robots probably will be part of the same team. So I think that whether we embrace these as a new goal for RoboCup, I think that's where the field is going to go. The field is going to go towards these human-robot interaction rather than these kind of like the chess player beating the human chess player or the Go player beating the human Go player. Because of the actual game of chess or game of Go having been not a team games, we kind of like designed this goal of RoboCup initially by Kitano with this trying to defeat the world soccer team, the human world soccer team. However, we kind of in our initial goal missed, I think, that team concept. And so there is the real thing is that chess is a single person, Go is a single person, I don't know, everything is a single person, but soccer is not. And the world in some sense are about teams. And what I believe we should have is like teams of humans and robots. So I think that these, and in fact, at the next trustees meeting, we should at least start talking about this new goal as a variation of the initial one. At least we keep the by 2050, and I think that that's something that I think it's very important. Okay, so it's 9:40. I have 5 more minutes. Let me just see if I can tell you a little bit about the research that I've done beyond the actual robot soccer, which is also very important, just to share a few more thoughts. Basically, because I was so used to reason about autonomous robots that perform tasks, I engaged around like 2009, 2010, I believe it was 2010, on building robots that would move in our environment. And the community had done these before, but these were completely autonomous robots capable of performing tasks with perception, some cameras, cognition, some machines to plan, and execution. And these became the cobot project, collaborative robots. And the reason why this project is so important for us is because this became a substrate for something that then also, in addition to my goal of these soccer teams with humans and robots, became part of a lot of my recent research, including now at JP Morgan. So my research has been on trying, or at least since then, because of cobot, it was not because of robot soccer. My research became because of cobot, that we understood that these AI systems have limitations, and no matter what, they basically, even if equipped with all the hardware or equipped with all the software, they might never be able to cope with all the physical limitations of that they may have, picking, not arms, picking, pressing elevator buttons, picking up objects, opening doors, and also the cognitive limitations. We can talk with these machines, but they might not understand what we say. So it became these, I keep saying these, people don't realize, but this was something that happened around, I don't know, 3 a.m. in the morning. And I was working with Joydeep Biswas, with Brian Colton and Stephanie Rosenthal at CMU to actually get these machines to move as reliably as our robot soccer teams were doing, and nothing was working our way. I mean, either the corridors were too bright, or the floor was like these, or the robot could not open the door, or the robot, it was kind of crazy how much limited the research seemed to be compared with the robot soccer, in which we could get the teams playing well in their little, the limited field. So it was in the evening, and I kind of like was struggling. Okay, I'm going to spend $20,000 more to buy some kind of arm to press an elevator button. We'll work on manipulation to pick up objects. We'll do all sorts of like connection with the internet. I mean, tons of things. And then there was this second in my mind that I said like this, but for goodness sake, these people, these robots, these cobots are surrounded by humans. And humans can do something. And therefore it became like this aha thing. We are going to include these robots asking for help from humans. Humans have fingers, they can press elevator buttons. Humans have hands, they can pick up objects. Humans can open doors. Humans can explain what they mean. And so it was a big, big thing for me. And if I think about my aha moments, like in robot soccer, in which we did tons of like research on collaboration, on breaking like architectures, on skills, tactics, and plays, to do learning on teams. I mean, there was so many breakthroughs there, but this one here in this ask for help was major. And then basically when the help was to actually ask for clarifications in terms of cognition, where is coffee, where is Manuela's lab, where is like the conference room, then the robot was learning all of these through experience, and magically this cobot has more than, I don't know, 10,000, 20,000 facts that it learned from this interaction. So it was a big change, this concept of being able to learn from experience through asking humans, and eventually learning from that help, be it from humans, be it from the internet. And at JP Morgan, I have the same, let me just, oops, oh, okay. I have the same kind of like concept that drives a lot of what we do here in terms of trying to, so let me just finish by showing you this. JP Morgan is huge, is an environment where there are many employees, many clients, many data, and basically the opportunities have been to do research on the problem of actually learning and getting feedback. Again, this concept of interacting with humans, and eventually improving these models. It's not trivial because humans may not give the right feedback, and the models may take a long time to actually improve, but that's where we are. And to tell you frankly, I think I'll finish here. I could talk more about the problems we have been addressing in the financial world. I'll be happy to answer those questions too, but let me just go back and basically finish my talk with just finishing with this picture and saying that, yes, I could tell you more about finance, I could tell you more about RoboCup, but in some sense we are here to remember Gerhard. And And I think that he would have loved to know more about my AI and finance work. He really was a person that cared about entrepreneurship and all sorts of like financial world too. And I would have had a blast talking with him about this, but unfortunately, he's gone. So thank you for inviting me. Thank you for Gerard for everything that he has done for us from a technical point of view and a personal point of view. And of course, my talk was just a very, very, very brief sample of a few things that I could share with you. Thanks for having me, Paul. Thank you very much.
Well, for this great talk. And I have to tell you that although we had, of course, some statements already, but there is still innovation. Of course, I'm collecting now in these memories which pop up now here and there. So one thing which I almost forget, but you brought up, for example, Gerd makes people smile, right? You were talking about the situation. So he was actually also fond of joking, right? And another thing which you brought up and which almost I forgot myself was he was writing very long emails, and you need actually a strategy to to cope with this kind of things. And yes, so actually, and also what you brought up, which I almost also forgot, is he was a real soccer lover, right? I mean, probably this ambition to really push the things in the committee so much was, I mean, because of this ambition to really get the ball rolling, I mean, literally saying, yeah. And of course, also what you mentioned was the strong voice. I like opinionated things and actually also optimistic. So he was ultimately really sort of more, I mean, respecting the past as learning from past mistakes, but sort of more always future-oriented and looking ahead rather than looking back. But I think there is a question from the audience.
Yes.
There's one question for the RoboCup community is about how to incorporate more underrepresented communities in RoboCup, and what are the plans in the RoboCup committee about it?
So it's a good question, so underrepresented ranges all the way from gender to ethnicity to, a lot of like a wide range. I do have to tell you that in some sense, RoboCup covers more than 40 countries. So we cover a lot of like of diversity, not in gender and probably not in ethnicity too. But we try very hard, and I cannot do more than being a role model to these women in the RoboCup. We do have also how do you say a very heavy component of diversity in junior. But we can never stop doing more. And for example, in our fall meeting coming, we have a fall trustees meeting. One of the things that we are going to also discuss is exactly more and more initiatives to increase diversity. And any ideas you have, we will welcome to hear. Yeah. So please share. We are a community.
Thank you. There's one more question.
Yes,
I
please.
think this is on the fun part. So based on your experience, and you also talked about collaborative soccer with human and robots working together. Based on your experience in a RoboCup football team in the future, which position in a football team would be easiest to replace can be taken by a robot?
Okay, this is very nice. That is a very nice question. But I don't know if anybody shared yet these 2007 when we played Humans and Robots. Gerard was the goalkeeper. Gerard was the goalkeeper. So, he was, he didn't let any goal go in. And I always had to say, Gerard, let some goal go in so that at least the robot scores something. But I think that in terms of position, so you have to say, I think goalie would be a good thing for a robot to be, because it's a limited field of view one way or another. It's a positioning problem. Of course, it has a lot of strategy, but goalie, it's something that I find very feasible to have a robot. And I also find feasible to have so I think that the harder position to have, like, for example, a defender or an attacker, I think the hardest position for a robot is midfield. And the reason why I'm saying it's midfield is because midfield, we don't realize, but it's that magic position in which you have to switch the ball coming from the back to the front. So, and it's like you have to be looking at the back and then passing to the front, while the attackers, in some sense, are always attacking. The defenders are always moving in the same direction. But the midfielders are these butterflies on the field that need to cover everything and guide the ball. So I think, in my very limited knowledge of soccer, that the midfield are the hardest positions for robots.
Yeah, picking up on that, I think this is a very nice answer. But how about intuition? I think a midfield player has to have something like a hidden representation of the actions of all players on the field. He sort of anticipates what is going on in his back as well as what is going on in his front. And so can you comment on having intuition for robots? I mean, do you think this is a possible achievement for robots?
Yes, actually, this is a very good point, Paul, because one thing that robots may be better to doing than humans is, in fact, using the data. So,
Sure.
in some sense, these robots are going to absorb all data from past games, from these games, and much more. Humans have some limited memory, or they have their own opinion of the data.
Right.
The robots may be more objective in terms
Yes.
of really using the data. So indeed, if the midfield position is a strategic kind of thinking position, then indeed it would be good for a robot to be there. It's more like the actual physical motion, I believe, makes it more, and the perception that makes it more.
We believe it's intuition, but it may be data, right?
I think it's data.
It is, in fact, yeah, which is proved by Leeds United, by the way. But this is a different debate. Leeds United is buying now players based on these probabilistic models, where they can go, where they can pass, and obviously they are quite successful right now. Manuelo, thank you so much for having us with us. Will you be able to join at roughly 1.5 hours again for our round table? Will it be possible?
I'm ready to join. Yes,
okay, so then we see each other again. Thanks again for this intriguing talk, and see you soon. Bye-bye now.
Thank you. Bye-bye.
Okay, and for the audience now, there will be a short intermission and break, since we are going to continue at 1600 with the talk of Pedro Lima about control theory and robots. Thank you for being with us, and join us again. Bye-bye. Welcome to our next talk today in our Memorial Symposium for Gerd Kretschmer. The talk is being conducted by Pedro Lima from the University of Lisbon. Hi, Pedro. And I'd just like to review your CV very briefly. You have been educated at the IST in Lisbon and finished your degrees in 84 and 89 on electrical engineering and computer engineering. You did a PhD on electrical engineering in 1994 in Rensselaer Polytechnical Institute, New York. Your research interests are mostly systems and robotics, especially control, cooperative perception, discrete event systems, task planning, especially under the constraint of uncertainty. And you participated in very many EU projects, FP Frame Program 7, and you have been the chair, the granular chair in 2004 of the RoboCup competition, World Cup competition in Lisboa. And you are going to talk about control systems perspective of intelligence robots. It's your stage for 30 minutes now.
Thanks so much, Paul. Thanks a lot for organizing this, a very deserved event like many others that have been going on to Gerhard. Thanks also to the team, particularly to Dibul, with whom I interacted more. And today I've been watching most of the talks before me. It was wonderful. I opted to bring a topic which actually I like a lot. I had to prepare slides from scratch just to kind of bring it to whoever is attending, and also because it was a topic that sometimes I would discuss technically with Gerhard, which was this kind of always there balance and trade-off and fight between the control systems and AI perspectives in robotics. But I would like to, before that, as many others also did, to tell you a little bit of the so many years and interactions I had with Gerhard. In fact, the first time we met was when we also started with my team in RoboCup in 1998. And very curiously, the first goal of my team was, I'm sorry for the sound, was in the game with the Young Sparrows. So you could hear all the excitation in the sound. And curiously, Gerhard's team had a catenaccio-like kind of strategy or tactics. As you can see, they were like moving the robots in front of the goal to avoid any goal. Later on, so this was 1998, 2 years later, we also faced them. And you can see that Gerhard's robots were designed very much at this image, big robots, powerful. We actually took advantage of that to score a goal in a penalty shootout with the Sparrows, because the robot would occupy so much of the goal that we could see what was the yellow part that was more empty and kick the ball till there. So this was pretty nice. Of course, maybe he did not like it so much, but we had a lot of fun. And in the end, we always tied against human Sparrows, which actually is very nice to think of. In fact, I mean, this was kind of my start in RoboCup. And I must say that kind of what happened next was a lot driven by Gerhard's passion. We started this team out of a project together with colleagues, in fact, colleagues of AI, while I was more on the control side here in Lisbon. And a few months later, Manuela came to give a talk, and she told us about RoboCup, and she said, you guys have to go. And that's why we went to 98. But then I met so many people who are good friends now, like Daniele and many others. But in particular, Gerhard and his passion were determinant, because, I mean, you can see him here. He was passionate about football. He was passionate about Bayern Munich, about the Die Mannschaft. And we were always discussing all these issues. He was always saying bad things about Cristiano Ronaldo. And this was a lot of the very nice fights that we had, discussions about these issues. And in fact, while discussing the rules of the middle-sized league, which for me, I was a rookie at the time, I was very enthusiastic about it. He was the chair, I think, in 1999. And I used to dispute a lot of the things that he was talking about. And as usual, it was very normal that Gerald would disappear for like 1 month while the other was discussing the rules. We were kind of proposing a lot of things different from what he had said in the beginning. He would come back like 1 week before the event and say, no, this will be as I said. All he said was wrong. So I would just come back very upset. And because of that, somehow he liked it. And he proposed me for the executive committee, and I started there in 2000, and later on as the MSL chair in Seattle in 2001. And so this was really something I recall a lot. Then we, at the European level, in fact, it all started in Graz because of some meetings we had with the head of the European Union, European Commission research unit on AI and robotics. There was this opportunity that we could have the first project on robot competitions funded by the EC. And actually, this was called the Rocking. It started in 2014. I was coordinating. You can see here people attending and presenting today, like Daniele, Matteo, and of course, Gerhard. And definitely, this also happened a lot because of him. The effort continued. There was another project, Rocky U2. We started European Robotics League. We had this joint event of like starting it, the cooperation with the RoboCup in Leipzig. Of course, it was again Gerhard who proposed this idea and who pushed it on. And this was the project currently running, where Gerhard was in the beginning. It's called Shirok. It pushes still further the concept of robot competitions in Europe, also on smart cities. And we have been collaborating a lot, but also through Luca with RoboCup and trying to bring ideas from RoboCup to this and try to push some ideas on particularly benchmarking that we will talk about later today to RoboCup from here. So the thing is, we really had a lot of meetings. The last time actually I was with Gerhard was, kind of twice. Once we had a dinner together after being in Bordeaux to like the contact trustees to prepare the edition of 2020 that now will be 2021 there. And we talked about a lot of things, including his thoughts about his current condition, which I will never forget. He also came to Porto for the National Robotics Festival, and then we had very nice dinner and conversations with him and other Portuguese friends like Luis and Fernando. He even came here twice to Lisbon, and even came here to my place. Unfortunately, I could not find pictures of that, but there was really a great relationship which somehow sometimes was even more joyful because of the strong discussions we had about football, politics, science, and so on. And one of them, as I said in the beginning, was about this usual balance between what people in control, which is my original background, and people in AI do when they approach autonomous systems and robots and so on. And in fact, for me, this was already kind of an interesting question when I was doing my PhD, because of somebody else that I also miss and value a lot. My advisor, George Saridis, was the founder of Robotics and Automation Society. He had come up with this theory of intelligent machines in the 70s that was very disruptive within the control community. And in fact, for George, this was kind of an intersection of three areas: AI, control, and operations research. And when I came to RoboCup, actually, a lot of these things that George Saridis was discussing with his students and colleagues, I had been in some discussions with people like Alexis Maistel, James Alvos, Rodney Brooks when I was a student. they organize these discussions about architectures and so on. When I came to RoboCup, this was kind of revisiting and kind of restarting these big discussions, because I was before that too much used to just talking to the control people. So I started talking to the computer scientists, I started talking to the AI people, and I really am now, for me, not anymore either a control person or an AI person. I feel like a robotics and AI guy, like the jargon says these days, because of all these influences. Josh Saridi's theory of intelligent machines actually was proposing an idea which today is kind of implicitly used by everyone, though he's not so much cited for it anymore, which is this idea that intelligent systems should have three levels. One of organization, which is, he was very much inspired by management for this proposal. One of organization, which is an abstract level where you say what you want to do in terms of organizing subsystems of your robotic system, of your intelligent machine, if you want. One of coordination, where you split this into different coordinating systems like vision, for navigation, whatsoever, and the execution, which is the one closer to the physical layer and where you actually control the hardware directly, like having control systems, processing the information from the sensors and so on. Now, how did this relate and how do I come from here to bring some of the thoughts I had today, and some of them I use also to discuss with Gerrit. I will go through some areas where I see these usual approaches which are more or less converging, and I'll try to show the two sides of the coin. Usually, of course, I'm a bit more influenced by my urge to provide a formal view, being more of a originally control background person. But I really will try to, for those who are not keen with it, to show how these things beautifully have converged somehow. One example I start with is on formation control, a very popular topic these days everywhere. The literature is kind of flooded with it, but it was a typical example of something that had interesting contributions closer to the AI field. And I brought here a paper from 1999 by Tucker Block, actually a former trustee, and Ronald Arkin, where they proposed a very well-known paper where behaviors would be used and blended to ensure that the team of robots would work in formation. And the way they do it is kind of more generalized here in Ronald Arkin's book on behavior-based systems, is that you have several behaviors, and this is a bit also rooted on Rodney Brooks' original idea, that can all in parallel process the information from perception, and then somehow you combine them by a coordination function to provide a response. And in this concept, what Tucker Ron proposed was to have behaviors such as each robot should move to the goal, it should avoid a static object, but they should also avoid the other robots. They should make sure they would also keep the distances, desired distances to the others. And this was kind of a flexible formation that would deform in the presence of obstacles, but would still keep some geometry based on these local rules of interaction provided by the behaviors, very close to Craig Reynolds' rules for flocking in birds. At the same time, in the control arena, people were proposing algorithms which now have been more and more used in different flavors, and in particular I brought here by Leonardo and Fiorelli, where they actually kind of formulated this as an idea of somehow potential fields similar to that, but now applied to multi-robot systems. So what you see here are potentials associated to what the relation you want to your neighbor, and another one associated to one or more virtual leaders that guide the full formation, plus the dissipative force, which is there just to make sure that whatever motion you do, you don't kind of oscillate or do overshoots if there was no dissipation, let's say. So a lot of physical reasoning behind. For instance, the potential here that results into this force, which is the derivative of the potential, tells you that here, this is like the equilibrium position. Sorry, here this is the equilibrium position you want. From here and from there, you always return here. And from a given distance on, you don't care anymore because you are too far. So you don't want the robots anymore either to repel each other or to converge into the same position. We did actually some simulations based on this, and also some work to extend it to non-autonomic robots. Former master student, kind of pre-PhD at the time we had this master thesis, presented it in a conference, and it shows very nicely how this works. I mean, you see the virtual leader moving around, and the others trying to keep the formation, but also deforming to avoid each other if necessary, and to let the virtual leader in if he decides to do so. So this is an example of how the two views can achieve similar results by different approaches. One topic which is very popular these days, and where this is particularly relevant, is I mean, these two views is hybrid task and motion planning. People in the AI community have been talking a lot about this as one of the main issues these days, because there's a lot of work on task planning, there's a lot of work on motion planning, but usually they kind of live separated. So it's like task planning provides all sorts of actions for the system. The navigation actions go to a motion planner that decides which motion commands should send to the robot system. All the other actions, imagine like manipulating, grasping, taking pictures, speaking to a person, observing a scene and detecting objects there, they all go to the robot system, not to the motion planner. And basically what happens usually is that you can have different types of approaches to it. You can do things like in this work of Larry Full, others, and Safiot, Alexander Safiot's group. You can plan as usual in task planning. You can sample different ways of achieving this plan, and then you constrain them by kinematic constraints of the actual motion planner. This is one way, but there's many other ways in the literature of doing it these days. But they kind of are all of the same type of that you have a sequence, I put here like a state machine, of things you want to do. Like in this very simple example where you have this robot that is moving back and forth until a fire is detected and you should put it out. So this robot basically has three possible states, and to each of the states there's an action corresponding. So if it is moved to right, it has to plan how to move to right. If it is moved to left, it has to plan how to move to left. Of course, in this case, pretty simple because it's 1D. If it puts out the fire, it's because the fire was detected. It goes here and then it stops here and starts throwing water at the fire. And this is kind of, well, these are like motion navigation actions. This one is another type of action. So I painted in different colors to correspond to what's up there. This is, of course, a very simplified thing just to show you that this kind of decoupling of the two things is very typical, and people are trying to build hybrid systems that do the two together more elegantly. Curiously, in control, for a while, people started talking about what they call hybrid systems, and basically what they do is to have two types of states. The discrete states, in this case of a state machine, could be other type of representation. And each discrete state has an associated continuous state. I wrote the dynamics here of each of these three states. For instance, this one means that it's always growing. X is the state, it's the position of the robot in 1D, it's always growing. And it starts in -1 and grows until it reaches 1. And when it reaches 1, it will decrease until it reaches -1 and keeps moving back and forth until it detects an alarm, and in this case, it decreases its velocity until 0 to put out the alarm. Why do people care about doing this kind of models? Well, the control community was very much used, it's more traditional, to have state differential equations that describe the dynamics of the system. But they figured out, and actually Sarides was always fighting this fight many years before. That's not enough for when you move beyond relatively simple systems and you want also to take decisions and go to other levels of abstraction. So that's when they, talking to computer scientists, thought of combining machines and grammars and languages with this concept of differential equations to come up with first discrete event systems and then hybrid systems. The advantage is that you can check properties of the system, things like how long will the robot take until putting out the fire, will it ever reach the fire, can you avoid, not necessarily the case in this example, dangerous states, and what do you have to do to make sure that there is guaranteed. These things of formal verification, formal guarantees are very important in some types of systems that you may need to model like this. And a very actual example is, for instance, autonomous vehicles. And many in the industry people are requesting this kind of guarantees. They are not easy. Usually the price you pay for this kind of more sophisticated in terms of formalization systems is that they are much more complex, while on the other hand, the say AI solutions come up with smart ideas which may even kind of be simpler in terms of computational complexity to implement at the cost of not being so keen to formalization. Speaking of task plans, another point which I've been working on for quite some time, and where I see a lot of these similarities and differences, is task plan representation. I mean, if you look, for instance, at the good old strips, which is still kind of the root of many of the current modern planners, like PDDL and so on, typically what you have is a logic-based planner. It is agnostic to plan representation. I mean, like all the planners anyway, even the ones that I will mention next. Basically, it has to figure out a sequence of actions, sequence of operators in strips jargon that you need to apply in order to get from your current world model to the desired world model, which is not here. But and you move from one world model to another world model by checking the by operators. You check the preconditions of the operator against the clause set that defines the state or the situation of the current of the world currently, and then you apply the operator. And what the operator does is to add some more clauses and remove some clauses that were active here. And for instance, in this case, the robot was in room 1, there was a box in room 3, and you know that the door P1 connects rooms 1 and 2, and door P2 rooms 2 and 3. And basically, this move operator matches in room robot room S1. And so, because it wants to move it to room S2, it basically will remove the clause that the robot is in S1 and will add the clause that the robot is in room S2. It's a very basic and kind of already old approach, but which still is there in a bit more sophisticated form and logic-based planners. Now, what is interesting is that if you think of representing this in different ways, you will get different results, which basically trade off power of representation with power of analysis, as it's very traditional in computer science. And I've been pursuing, and this was still from the times of the work with Saridis and other colleagues there, I've been pursuing a lot doing this with Petri nets. Gerard used to joke with me saying these were Pedro nets, which for me was actually kind of something delightful, because I don't have the credits for that, but I would like to. And basically, in this very simple example, you see that you could represent the same idea. I mean, I'm not going to explain to those who don't know what Petri nets are, but basically you can have preconditions. When you have tokens there, it means that they are satisfied. That is, the robot is in room S1, the box is in S3, and so on and so forth. And when they all are satisfied, you can go over this transition and start moving. So some places are associated to predicates, others are associated to running actions, like moving the robot. And once you stop moving, you are now the robot is now in room S2. Remember that the robot was not anymore in S1, was not yet in S2, and these are like reflexive arcs and the simplification of 2 arcs that should be there, meaning that this does not affect where the box was and the connection between the doors, which is what is also here. Now, why using, for instance, Petri nets, could be state machines, could be other types of representations, can have some advantages at the expense of losing the power of modeling against, say, behavior trees or other representations. Well, because you can tackle a lot of interesting issues. You can have non-deterministic control policies for which you can associate a probability mass function over the actions for a given state, meaning that you can choose between those actions. You can even use reinforcement learning to learn over time what is the best action. You can actually execute the Petri net using the firing rules, but you can be event-based, rule-based, or a mix of the two, which is also interesting since a lot of robot systems are very much event-based. But maybe even beyond that is the fact that you can have different views of the model, which allow you, depending on what you want to do in terms of analysis or even of synthesis, which is kind of an old dream, you can analyze formal properties, such as if the plan goes into a deadlock, if it is conservative, if it is live, and so on and so forth. Or you can go into another view, a quantitative view, particularly if it is stochastic, where you can study properties of the system, of the plan, in terms of handling uncertainty, such as how successful it is, how robust it is to the fact that some of the actions at some point are not as successful as they should be. I have an example that we built many years ago to illustrate this. You have, let me just stop it a bit to explain the initial scenario. You have these two robots of the same team they're going to perform a pass. This robot from the other team is just there to kind of illustrate that there may be opponents. And these are the Petri nets for each of the two robots. This guy is the one that has the ball, this one. This guy is the guy that is going to receive it. And in this case, the Petri net illustrates a multi-robot plan. So at some points, you will have communication between the robots, which is represented here. And this is one of the things that I would like to call your attention later on the advantage of using the Petri net. So this guy is with the ball. So there's a token there. He has the, I'm sorry, this guy is moving to receive the ball. There's a token there. This guy has a token, meaning he has the ball. This is all very slow on purpose to let you understand what's going on. Okay, now this guy reached the reception location, and he is waiting now for a pass, and he sent that information to the other. That's what this means. Or at least he sent it, but did not reach there. Now, this one has also reached the pass location, and now the message is being sent. So when the two places have a token, meaning that the message has been received and the robot is waiting to send the ball, now he can send the ball. And when he sends the ball, the other now is just in the situation where he says he made the pass. Remember, this guy was waiting for the pass to be made. And this is important because if you would go to the ball, he might just fight with his own teammate, and this is not good. So he waits, like a synchronization process, very well known in planning. And then this message is sent by the other to tell him, no, I passed the ball, so you can move towards it. And the message goes, the message has gone already. The two tokens were here, they were consumed, and now he's moving to them. Now, when I model it this way, one advantage I have is that I can, for instance, have here different communication rates and see the impact this has on the cooperative behavior. I could even add extra things like failures of communication to make sure not only that I would recover from it, but also what is the impact that the failures like this have in the full process, including if I would get into a deadlock, if I had to modify my plan to avoid that. This is just one example of where this type of representation can be advantageous. But there's also, and this is where I will finish, this modern trend, which I like a lot, of putting together optimal feedback control and planning. This has been on for some time now. It started, I mean, there were people working on MDPs, Markov decision processes, and on reinforcement learning, but basically you have a closed loop like in control, an agent that sends actions to the environment, and the environment reacts by changing its state and by sending a reinforcement signal to the agent. And the goal of you design the action to decide actions that maximize a cumulative reward function. In control for quite some time also, there was this optimal control. Well, this is a typical closed loop control. You can design control in many different ways. One of them is using optimal control. For the general case, you have an equation, the Hamilton-Jacobi-Bellman equation, that causes you a lot of troubles to be solved in real time, or even to be solved at all, even numerically. But in some particular cases, like when the system is linear and the function to optimize is quadratic, like this one here, you can come up with solutions even in closed form with a closed loop. And you have the linear quadratic regulator that looks at the state of the system, and looks at the reference and provides optimal controls. Look, that again is kind of the same idea: the agent, the environment, the feedback, and function you want to optimize. In this case, you want to minimize this as a cost that balances the error of the state and the effort in control. If you have noise and you have to estimate the state because you don't observe it directly, you observe the output, then you have an LKG controller. And this is very similar again to what happens with the extension of MDPs to POMDPs, which are the partially observable MDPs. Everything remains the same. This is much more difficult to solve. Here, maybe not so much more, but also we are assuming linear system and a quadratic function, which simplifies our life. If we go to nonlinear systems, it will become much harder. And people are now very popular, kind of reinvented optimal control, this MPC, model-based control, because of the speed up of numerical solutions, algorithms that allow you to, in real time, solve some horizon ahead of you, determine the optimal control law, and then you apply it once and you replan again, which is a lot what some of the original planners also did when they abandoned the basic problem and had to accommodate changes and so on. So one big discussion these days, which as Manuela was saying, that we are moving into data in RoboCup, and lots of data, lots of learning, is how to use machine learning for feedback control. And there are at least three main views and a lot of discussion going on about them, whether we should learn the system model for model-based controllers like MPC I just mentioned, if we should learn the estimator and reduce the dimension of the state from the output. This is particularly valuable if the state is quite large, like if you go from image pixels into features. So we want to reduce it a lot into the features, but we used to do this manually. Now we would like to learn it. Or if you just want to learn the controller directly. I remember, for instance, Martin Gridmiller doing that, just mapping pixels in the image directly to controls to the middle-sized robots, and he was very successful doing that in Robot. So I'll stop here with some thoughts to take home. One of them is that, fortunately, and for people like me, this is great. Control, AI, machine learning are converging in many, many different aspects. Multidisciplinarity is great, and so it's good that it's happening. But I miss my friends with whom I used to discuss this a lot. I put here a picture of the last time I was together also with Fernando and Luis, who were today and in the past days, and also of George. I hope I can keep discussing it with many other people, including many of you. So thanks, and I'm ready for questions if you have some.
Yeah, thank you very much, Pedro, for this tour de force on the intersection between machine learning and control theory. Maybe you recall that I'm also a big friend of control theory in the sense of it's seemingly more deterministic, let's call it this way. Yeah. But who knows? Yeah, I mean, one never knows. Yeah, but coming back to your very last slide, you mentioned the impact of data and learning, right? I mean, of course, here two contrary positions sort of collide, yeah? Because on one hand, I mean, if you go the control theoretic view, I mean, you have very strong assumptions on the working of the world. I mean, physics is on your side. All the modelings from physics is there, and you can rely on it, and it will be sort of given, and you can take it for granted, and so on. While on the data side, you have sort of to reconstruct the world, right? I mean, it is sort of hidden in the data. Of course, everything is hidden in the data, but it may just take ages to sort of reconstruct the really nitty-gritty from this data. And you mentioned here the features, for example. Yeah, so of course, the data may have a chance to enhance your controller by providing some additional or whatever things. But my real question is, although the architectures which you present, they looked similar, yeah, but do you see a way to transform them from one to another? Because, of course, this would be then a very strong argument that this underlying phenomenon actually benefit or could be mapped to one another. Yeah, so like that there is, let's say we look at this as a graph, yeah, and then we sort of make a transformation procedure from A to B, and by this sort of can reconcile these two worlds of control-based versus possibly purely data-based or machine learning-based. So is there some meta theory on that?
Not that I know. And I look at it slightly differently from that. I understand fully what you are saying and what you are asking. I think that the current approaches go a little bit more in a, I wouldn't say it is different, not diverse direction. I brought this one here again. Of course, I oversimplified. I didn't want to give a lecture. That was not the purpose at all on these topics. In some of them, I might not even know enough detail of what is going on in some aspects today, because there's a kind of an hurricane of literature of people doing great things. But first of all, what I showed here that is kind of similar is this idea of closed loop, where you have a controller, which is the agent, and where is the system, which is the environment. Now, what is happening is that while here people were basically putting this not so much as a control loop, but as we all know, as this agent, the environment interaction, and what the agent has to do to maximize reward. Here, people always thought of it as a closed loop, and they wanted to find a way of designing the controller. Now, what happens is that most of the time, for many years, and I mentioned George Saridis very often because he was kind of fighting against that early, people would never go beyond relatively simple systems. Maybe sometimes it's kind of misleading calling them simple. I mean, if you are controlling an airplane with a multivariate system or a boat or a submarine, that's not a really simple system. But they were essentially, as you said, mechanical systems for which you know well the model, as sophisticated as it may be. So you don't have to learn it. And maybe you also know the essential of what you want to know around you. You need to know where you are, so you observe, you get information from GPS or laser scan and so on. Now, the problem is when you wanted to do the same for a system like you have an autonomous driving vehicle, and he has to handle its driving, but also everything. If there's people crossing other vehicles, the traffic signs, and how do you manage all this?
Right.
And the people in control lately is a lot doing something that the people in AI were already doing, which is either learning from data or not, much more learning from data now, is to face this kind of high level of abstraction. But they realize that then they cannot anymore like take advantage of having a model of the system. And that's when they, for instance, learn the model.
Yes.
I've seen also recently very interesting talks. There's, for instance, Professor Ben Recht in Berkeley that has been talking about how these things compare with an approach in control. He knows very much of the two fields, actually, ML and control. And he says that in some cases, learning directly the controller or the model may not be advantageous because you can still solve it with kind of robust control or other stuff using the model. But in other cases, particularly reducing the feature dimension and so on, this can be definitely very advantageous. This is what he says, and I kind of like it, but kind of just stop there because
Yes,
I
yes.
should know.
Yeah, because we are sort of running out of time. But nevertheless, I think
Right.
you made a good point, or a very future-directed point, namely looking into autonomous driving, because, of course, this is something like an applied field where the two worlds need to reconcile their views, because, I mean, we have sensing and complex sensing because it's happening in the real world, while we also have a mechanical car which needs to be controlled, and there has to be something like a decision or deliberation algorithm going on and tell the car what is it doing now and here, and having a pedestrian in front, and well, all these circumstances which might happen in a real driving situation, right? So there is definitely, I think, a need for making these two fields merge, or to agree, or to sort of come up with a solution how to reconcile all the things under one hood. And I think we will have a good opportunity during our debate when we do the roundtable after Matteo's talk, who is already in the back of me. And thanks for presenting this very interesting, let's say, view on these two worlds. And I hope to see you again then in a couple of almost minutes. Yeah, it's not exactly roughly 1 hour, let's say. Okay.
Exactly.
So thanks again for presenting, and we'll have now a small intermission of 3 minutes, and we are going to then carry on with Matteo's talk. Thanks again, and see you in a second. Bye-bye. Hello and back again. I'm happy to present our last speaker to you, and this time again live on stage, Matteo Mattiucci, who is from the Politecnico di Milano. He did in 99 graduation at the Politecnico Milano, and after that actually joined for a certain period of time CMU, where he was advised by Manuela de Veloso and did a Master of Science in 2002. Actually finishing ultimately his PhD thesis again at the Politecnico di Milano in 2003. His research aims have been and are robotics and machine learning, and he participated in very many EU projects, too many to mention in this in this short period of time. So Matteo, the stage is yours for the next 30 minutes on benchmarking through competitions.
Okay, thank you, Vas. Thank you very much for introducing and for inviting me. As you mentioned, I have been working on quite a few projects, but today I would like to talk especially about one, which is the Rocking project. It was already mentioned by Pedro Lima. He was the coordinator of this project. And I would like to talk about this because, well, because it has a legacy. And somehow this legacy is related to also Gerhard and the interaction with him. I'm the last of the day, actually last before the panel of the entire symposium. So I thought it would have been kind of late to talk about Gerhard. I mean, I think everything should have been said. So I decided to talk about me and, in a sense, how I stopped worrying about RoboCup and I started to do benchmarking. And while talking about me, it's impossible to mention Gerhard and his influences. So it will be a sort of picture of Gerhard through a picture of myself, so a self-portrait. Any story has to start. I shouldn't start too early, so I decided to start in 2000. Why 2000? Well, 2000 was Amsterdam, was the first time RoboCup was held locally in Europe. And as you can see here, the organizing co-chair was Gerhard. So that was the first time I met Gerhard. And actually, I was kind of advised about meeting this person by my advisor at that time, Andrea Bonarini, who introduced me to RoboCup. He said, you will meet Gerhard. It's an interesting person. And indeed, it was actually. I don't like pictures, so I usually don't take pictures. So I feel myself always a little bit in a trouble when I need to make presentation because I have to Google for pictures. And indeed, I Googled for this, and I was lucky enough to find a picture of that day with myself on it. So hard to tell, long hair, you know, but that was me at the very first year of my PhD. Then I got dragged into this RoboCup thing, and I was in Lisbon 2004, and I think this is out of one of Pedro's album or some friends' pictures, and it was again me in Lisbon 2004, where I ended up meeting Pedro for the first time. He was the chair of RoboCup in Lisbon. And then I was still dragged in RoboCup, and this is a video of a team, well, a game of our team. We are the purple one playing against the blue team. So, I mean, you cannot hear, but there's my voice cheering for the robot in the background of this video. And you see how our robot was very agile and was very, I mean, aggressive in a sense, but was very, let's say, intelligent. But we found out that this doesn't pay off. So, you know, as any soccer fan, at some point your team doesn't win, and so you have to blame someone. So who should I blame for this? And you end up blaming not yourself, but you blame the referee, you blame the field, you blame the spectators, you blame. So I decided to take a step further, and I blamed soccer. So I decided to move to something different because I felt myself there was not real benchmarking. So I could not admit that I was not good in programming robots, so I should have found something different. But I was not the only one. I mean, it was the time where benchmarking of systems, intelligent systems, were very active. As Paul said, I've always been between robotics and machine learning, and I was looking at what happening in machine learning, and there was a lot of, and computer vision, and there was a lot of benchmarking ongoing, so we can date back benchmarking to those years. So I decided that I wanted to do more or less the same thing in robotics. And the first thing to start from was perception, and in particularly SLAM. So probably SLAM is the icebreaker of benchmarking in robotics for several reasons, so maybe because it's easier. So I decided to start my first European project, which was called ROSITS, and it will come later on. Another set of initiatives were ongoing at that time in Europe in the EURON, which was the European Robotics Group network, and a working group started discussing about the good experimental methodologies that we should have taken when looking at robots and intelligent systems from an experimental perspective. Eventually, this became a mature topic. There were also IEEE schools. Here there is one of the schools that we had in 2015. Among the people, the teachers of this school, you can recognize me, Daniele Nardi, Pedro Lima, who have spoken today during this meeting, and eventually a special issue of the IEEE robotics and automation. And I think that this group has led forward this idea. At that time, I came back to competition. Why? Because in a sense, my roots were in RoboCup on one side and in my effort in benchmarking on the other side. And here it comes Rocking. Rocking is probably the first step back to competition that I did after I left RoboCup, and indeed was a project funded by the European Commission, coordinated by Pedro, where Daniele Nardi, Gerhard Kretschmar, Rainer Bischoff, and myself were doing the research part of the project. It was taking inspiration from RoboCup and trying to promote some of the benchmarking ideas. I mean, I must admit that it was not an easy task, because I had to pass through the Kretschmar Commission, because the project was led by Pedro, Daniele, and Gerhard, and suddenly I somehow promote myself to become part of the team. And I know that they had some discussion. I mean, with Gerhard, you always fight a little bit for everything, even for deciding about the beer. So at the end, I was part of it, and I was very proud of becoming part of this project, especially for the objective. One was reducing the, let's say, subjective evaluation of team. This was talked by Luis this morning at the very beginning as one of the issues of RoboCup Junior, and the other one is to become more repetitive and have a way to compare teams across years, and that was one of the ideas. This was part of a movement of research. Different people were thinking that the competition are a marvelous way of looking at robots outside the lab, and this is something that we haven't really discussed today. Why competition is so important is because the robot works outside the lab, and this is one of the critical aspects of a system if we want to work in the real world. Real world. I will come to this concept later on, I promise. So, and a second point is that there was a big emphasis on challenges. So a sort of one-time demonstration. We can think about the DARPA challenge. You do it once, you solve it, finished. But if you do not keep repeating it, it's hard to keep track of the improvement, of the evolution. And I think that competition like Rocking, RoboCup, and many others, which are repeated in a consistent way among years, are a way to monitor these, let's say, progress of science. Indeed, the idea of Rocking was to look at the competition, and I think this is the real different view of rocking with respect to other competitions, was to look at competition as experiment. I mean, there are different kind of experiment. You can have a feasibility experiment to prove an idea, some trial experiment, or, I mean, the golden standard of science, which is the controlled experiment. I mean, we do not pretend a robotic competition to be like a controlled experiment, but we would like to have them as a comparison experiment, what we usually call as benchmarks. So we would like to set up this competition so that you have two, let's say, solutions that compare, and you are able to state in an objective way whether to solve a specific problem, one solution is better than the other. So this was the basic idea we started from, and we had immediately to face a problem which was different from all the other competition that I was inspired from. All of the previous competitions were mostly dealing with perception. What's the real difference? Well, the problem of other competition is they first look at perception, where you can save data and then post-process the data. Second, they didn't look at integrated system, which is something that Gerard was really keen on. I discussed many ways, many times, how just integrating the right component in the wrong way would make the system fail. So a system, that's why we like robotics, because it's a system, it's a science of systems. Well, this makes difficult to understand, to evaluate what is due because of the algorithm and what is due because of the integration. And this was part of the complexity of robotics and competition that we wanted to look at. And this, again, dates back to the ideas of system engineering, of software engineering that Nico has spoken this morning. Understanding at the system level, at model level, how a robot works is one of the way of designing its behavior. I was mostly interested in measuring the behavior, and the main issue in this is that, is a sentence that I keep repeating when I talk with my friends Pedro Lima, is that robots are doomed to close the loop. The loop is the control loop we were talking. So we cannot record the data because the robot is changing at any time the environment is working with. We have to test, evaluate the robot in its environment. So the problem of testing a robot in its environment poses, let's say, two challenges. One is, should we test the robot on a complex task? For instance, please bring me a glass, or prepare the room for me, or at the level of a single functionality. For instance, grasping, manipulation, perception. This kind of dichotomy is what has basically led us to design rocking in such a way that we would like to test, to benchmark during the competition the system at both levels. Indeed, one of the objectives in the rocking idea, these slides are from the original rocking presentation, is to evaluate the quality of system and subsystem through the competition. That's why we observed how most of what we call the performance evaluation in intelligent system focuses only on functionalities. While, on the other hand, competition, they mostly challenge tasks, so complex activities. And we tried to design the rocking competition by identifying the tasks, but also single functionalities and building what were the functionality benchmark. This view is discussed into two deliverables. Probably this is the only presentation which takes deliverable of a project as, let's say, scientific literature. But I want to discuss this deliverable because, again, I mean, this one was curated by Gerard personally. And this picture was drawn by him together with the BRCU team. And we had a hard time because we had a different idea. So if you look at the Rocking project, in the, let's say, framework, there are two deliverables. And they tried to bring two ideas. We had a hard time in figuring out which was right, which one was wrong. But at the end, I think that we managed to harmonize these two different views. And we did such a good result that I think that what came out was named by the Rocking project officer as Rocking Legacy. So at least in the words of the project officer, Anne Bajard, which was a very close friend of Gerard as well, the Rocking Legacy was this framework, and indeed this framework was later on published in a paper that Nico this morning has shown as well. And you see, well, you cannot read the names in the paper, but Nico, myself, Daniele, Gerard, Pedro are among the authors of this paper. So after Rocking, many other projects came out. I want to name two of them, Euroc and Eurothlon. There were two competitions which we were not involved in. Why do I want to name them? Because the project officer was so inspired by this legacy that asked us to start collaborating with those projects, trying to shape a European vision on benchmarking of robotic system and a European vision on benchmarking through competitions. So I gave a speech at the, let's say, kickoff of Euroc, and we interacted constantly with Alan Winfield for the Eurothlon. After that came RockU2 and the European Robotics League, which basically took the Rocking legacy of a functional benchmark and task benchmark at the more distributed level. So we have many test beds around Europe. One is here, and one is in Lisbon, for instance, at Pedro's Lima's lab. And after this, we moved forward to another project, which is a Shiroc. Rocking, Shiroc, they have been named by Pedro in the previous talk. And I think that they come out of the Rocking legacy. So this way of looking at competition as benchmark. After Shiroc, we have now Metrics. Has not been named today too much, but Nico has talked about this, and is the last project Gerard has worked on. I was with Gerard at ELF. He was writing with me the proposal. The project passed. Unfortunately, Gerard will not see the end of this project, but I think that it's the next step forward. So many projects, a long legacy from Rocking. You might ask you at some point, are we done with this? Did we reach a sufficient level? And I would like you to spend 5 minutes with me in giving the answer to this question. But to do this, I will ask Gerard to give it for us. So a little bit of Amarcord. These are the original slides that Gerard gave at the Rocking kickoff meeting in 2013. So are we there? So Gerard was, was very provoking. He liked to give very strong statement and to push it to the limit. This was the kickoff meeting of the project, and he thought that the very first day was already the time to give a kick to the table and raise the bar even more. It was a Gerard style. So I would like to look at the last sentence, and the remainder of these slides are supposed to show some features of real environment. And if you know Gerard, you can understand immediately what he means with real environment. His house. So what he did was going around his own house, shooting pictures, and asking himself, what if I want to listen to music? Would the robot that I have in the lab, able to do that? And this is a question that I'm posing to you. Are we there yet? What about reading a book? You might ask which book. Please think about the same task, how it is proposed to robot today. This morning, Luis was talking about simplifying for the teacher the task. The question that Gerard was saying, are we simplifying for the researcher the task? And we shouldn't, because real life is like this. And you have obstacles. It took me a while to understand where is the obstacle. How long would it take to a robot to see this obstacle? And what about setting up the table? I mean, you have to take, I don't know, plates, cups, bowls, and then for the coffee table, the spoons from here. Think about your robot dealing with this task. What about the daily used stuff? And what about glasses to prepare a drink? And, I don't know, napkins? What about the drink? Are you ready for this? And what about a real fridge? So I like these slides because they are very intimate. Gerard was always giving everything of himself. So I think that these slides are representative of what was Gerard's life and Gerard's research. They were the same thing. He was thinking about research in every single moment. Preparing a sandwich, I don't know, preparing some pasta for the food. I was astonished about the kitchenware that Gerard had, but knowing Gerard, his passion for food, not only for soccer, I think that you can immediately understand what's there. What about here? Are you ready to do the food with your robot with this? And I mean, we can go on and on and on. And I like these slides. I was looking for these. I knew that I had, because they give a piece of Gerard's lifestyle, and I think they're very nice. What about watering plants? And what about handling handles, which is one of the tasks that we might think. And he was looking at the complexity of task in everyday move. And that's what I appreciate of Gerard. And this is one of the lessons that he taught me about benchmarking robots or benchmarking science through everyday problems. I think this is the core of AI. I mean, AI has to build systems that are able to deal with this complexity that human deal every day after every day. More handles. And what about, I like this slide because it pulls out a control problem from an easy task. So what is the force that you need to open that drawer? I mean, I think that we don't yet have an answer in our research lab. And I think this is the stimulus that Gerard left in our minds after that. What about powers, switches? What about handles every day? So I will stop here to go through the slides because of time and because I think that we should look at the following slide with more care than just pictures. I would just like to put this sort of summary, which is one of the last slides of his presentation, where he tries to list what should be the priorities in research and in challenges in the design of a general purpose robot. Setting the table, taking care of people. Indeed, the competition that he was proposing for the Matrix project when he wrote the proposal was for health and elderly care robot. It was one of the passion of Gerard, one of the long-term goals, having robot helping people, helping society. And this was one of the main ideas. I also took some inspiration from his slide because I designed a benchmark for a robot opening the door. No time to go into the details. So probably, in the Gerard words, all these open issues are the rocking legacy. What's left from rocking is all these unsolved problems that robotic researchers still have to look at if they want to develop intelligent robots able to solve general purpose tasks in a real world. But I want to spend a little bit more of time also discussing what I think is the real rocking legacy. So the project officer saw a sort of roadmap in how to use competitions for benchmarking. I'm glad Anne Bajard had this view, because this has shaped some European research line in such a strong manner. Gerard had a clear view of what is the legacy. It's a legacy of unsolved problem. And I have another view. And to share with you what is my view, I would like to take a strip from Calvin and Hobbes that I will read with you, which is Calvin is asking his dad, how do they know the load limit of bridges? And the father says, well, you know, they build the bridge and they put bigger and bigger trucks on top of it until the bridge collapses. At that point, they wait the last truck and they rebuild the bridge, and now they know how is the bridge load. Now, obviously, this is a totally confusing answer for Calvin, but that's how we know our robot will perform in a real environment. We build our robot, we put them in the environment, we observe, we measure this robot in the environment, and then we know how that robot will perform in that environment. So if I tell you, take your robot to this new environment, and before even switching this robot on, are you able to predict the performance? I think that we still are lagging behind in the tools and in the instruments to predict the behavior. So, in a sense, robots should not be like bridges. I mean, the Calvin and Hobbes kind of bridges. So, I think that there are still some fundamental questions that roboticists, that research in robotics and AI has to answer. So, first of all, how do single components participate to the performance of a complex system? I think that competition, benchmarking competition, are a way to observe this, but we need the tool to understand, to predict this behavior. And in a sense, we would like to quantify how the results that we get in our lab will translate in the real world, which in a sense is Gerard's question, how our robot will be able to work in my house, in the real world. But also how a simple component participate to the complex system was one of the most striking questions of Gerard. How can we model a robot system? How can we design a robot system such a way that the final system will behave how we would like it to behave? And another question that I think we should answer is, can we design a robot that will perform as we want? So we should stop building robots, putting them in environment and observing them. We should start designing robots. And this, again, somehow calls for Gerard's passion for software engineering and for model-based robotics. So I think that these are, in a sense, what I think it's the rocking legacy. So what is remaining out of rocking and what we should work upon in the future, at least that's my perspective. What I should say is that these are a lot influenced by Gerard, are a lot influenced by the talk that we had with Gerard, talk that we had on during conferences, during workshop, during, I don't know, let's say dinner, before and after soccer game. Never talk during the soccer game. Don't touch it. I mean, it's soccer time, it's soccer time. And I think that Gerard has left a lot. And I think that he has left one thing that I really appreciate, which is friendship. I mean, today we are here, and it's like being a group of friends, not remembering a colleague, not at all. I think no one of us has ever thought at Gerard as a colleague. Gerard was a friend, and today we are here to appreciate how much has been the influence in our research left by this friend. So thank you for listening, and thank you, Gerald, for having influenced us so much. Thanks.
Thank you for this gorgeous talk. It was very, very nice. Yeah, and also actually reminding us of a lot of facts. Friendship, another thing which you mentioned, yeah. So, and Gerd was an architecture guy. He wants to work for systems, right? So there's always this systems perspective thing. Yes, but now, since in your topic, I mean, in the title of your topic is benchmarking, and benchmarking is already some of the main topic of the follow-up podium discussion, I actually would like to refrain from my personal questions because as I learned only 5 minutes ago, I will be actually now part of the discussion. So originally I was leading it, yeah, but now I'm sort of a part of it. And so maybe, Dibul, we should ask the question from the audience, if there are questions from the audience.
Talking about RoboCup at ICRA and IROS.
Well, that's a tough question. So I think it's not so small. In a sense, I mean, Luca Iocchi has shown how many papers and how many they've been influential for the research. And so I think that it is probably not the kind of, let's say, very blue sky kind of paper. They're very applied. They are very grounded in real life. Sometimes, though participating into competition puts you into problems that are more engineering problem than research problem. So I agree that the impact on science, provided the effort that you put into participating in a competition, is limited, no doubt. And this is known by every one of us. We all know that the research outcome with respect to the effort and time and, let's say, frustration that we get from competition is negligible. But still, I think it's an advancement. I think that, let me make a very simple example, and then you will see. I think that without the DARPA challenge, we wouldn't have had today this big phase of autonomous vehicle. So without the ImageNet competition, we would have had today this big phase of AI. It would have come. I mean, I'm not saying that it would never come.
Right.
But I think that, so if you look at breakthrough, many of these comes from a competition. You might not realize on a first step. I really think that they should be part of research. One thing that I didn't say, but I want to take this opportunity, I think that we, as a professor, not just as a researcher, we know perfectly the mixing, the intertwining of teaching and research. And I think that this was clear in Gerald. I mean, he was always pushing both.
Yes, yes.
The teaching, the STEM, the junior, but also Rocking and all the projects after, they have camps for students. I think that this has not to be underestimated. And many of the researchers, they publish a lot. If you look at their background, at some point they did some competition. Maybe they left because of efficiency.
Yes.
Probably because
I
of
agree.
efficiency.
Yes, yes.
So I think that when you're a youngster, you have a lot of time, and I think part of this should be devoted to a competition.
Right.
It will help research a lot.
I think the next question is also related. It's, since you mentioned the DARPA project, a little bit controversial, let's say. In terms of benchmarking, the large US robotics community seems a bit detached from the European benchmarking efforts. Why do you think that is the case?
Well, that's okay. I don't know exactly what does it mean detached or in which sense. I think that we are following different paths. And this is also related to the strategy that has been put. I mean, there are US effort in verification and formal verification and performance evaluation. I mean, just to name the NIST effort overall. I mean, we cannot think about benchmarking of systems and not think to NIST. So I think that we have the same effort in benchmarking US. Maybe the way it is implemented, we don't have an institution like NIST in Europe. That's an example. So probably is more a structural thing. I'm not saying which one is the right thing. I'm not saying whether Europe should go on his own strategy or on a different one. I think it's good that both exist. But I don't think that we care differently. I think that the strategy is different. The DARPA, both the DRC, not only the are examples that this competition thing is ongoing. I think that, right, there is a detachment because the instruments are different,
Right.
not because of the goal is different. So I must say this way.
Thank you. I think that's where the questions from the audience.
Okay,
Yeah, so thank you once again.
you're welcome. Thank you for inviting me.
Yeah,
to
you,
this,
you are. It's a
great
pleasure
day.
to have you here, especially in person. And I have to make now a special announcement because during the refurbishment of this setup here, there will be actually a chance for the relatives of Gerd actually to participate in this event. And so I think they will have a chance to meet us now and give a word of greeting to us.
So that's a
Well,
plan.
14 days when you come back, right? I'm
Oh.
not completely
No,
sure.
no, in Germany. I'm not sure coming back, but in Germany for sure. It's on the
Hello.
way there.
Hello.
I see.
I'm with you now. We are on live now. Hello.
Hi.
Hello. Hello. Here we are again. Yeah, it's a very big surprise that actually our active participants have now enlarged by more persons to join this roundtable at the very end. So actually, I like to welcome Iris and Thomas Kretschmer, who joined us for this very situation. Furthermore, I would express my gratitude to you that you first of all have been watching this event since Monday all week long. So probably you are our most frequent viewers or something. I mean, don't forget the thumb up thing in wherever, I don't know. Furthermore, I would like to express my deep thanks to you, since you were willing to share also this private in part. Hello, here we are again. Yeah, it's a very big surprise that actually our active participants have now enlarged by more persons to roundtable at the very end. So something is wrong here?
No, I think it was my fault. Sorry.
Oh, okay. We found someone. Okay.
Too many open windows.
Okay, so then just again continuing. So thank you for sharing this allowance and permittance to have also this very private, in some sense, information on your kind of family affairs in general terms. And as you know, we will have concluding for the whole symposium scientific battle, debate, whatever, round table. And I would like to pass the microphone to you if you like to mention or if you like to say something to all these family-like guests, I would say. So Thomas, yes, it's your stage now.
Yeah. First of all, thank you very much for having us here. It's a great honor to be part of this, and we were very happy to be invited and to see all these very interesting talks and aspects and people that remember my father. And so, yeah, and thanks a lot for organizing all this, also to the Bonn team. And yeah, so we are overwhelmed basically by all this gratitude and happiness that we can still see my father brought to a lot of people and to the community.
Yes, very much, yeah. So something more? No, okay, yeah. So good that you have been, yeah. And so from the structure of this, what is going to follow up now is you can feel invited to stay if you like to the debate. You may also actively participate, in fact, since you can open your mic whenever you deem that it deems necessary or something. So please feel invited to stay if you like. On the other hand, I think it's now time for the panelists to move over to our stage here. And with this, I changed my role, in fact, since I have been the moderator all week long till this very moment. But from now on, actually, Deboul is taking over so that I can actually also actively participate in the round table and take a personal opinion on those hot issues which are going to be asked and presented by Deboul. Yeah, so Deboul, are you ready to take over? Oh, okay, there is a very small intermission because the gentlemen need to be cabled. There is not yet a microphone on them. So just take 2 minutes submission, 2 minutes intermission. Yeah, so we have to have 2 minutes to actually change the microphones. Okay. Ja, den nehmen wir eine Zange. Hi, Dirk. No, he's not.
Hi.
How are you? You are looking great.
Yeah, I mean, as good as you can look like when you work from home. Place is a garage.
Okay.
Because the kid with all the like homeschooling occupy the whole living room and basically everything else.
Dirk.
So I have my safe space.
Be cautious.
Here in the garage.
Be cautious. Mentioning garage in Silicon Valley. You know what might happen in garages in Silicon Valley, right? I mean, don't complain. This garage may be the start of a brilliant new career.
Maybe.
Okay, now Dibul is ready.
Good. So yeah, whenever you're ready. So hello everyone and welcome back to the Gerhard Kretschmar Memorial Symposium. It's been a week long of symposium to commemorate Professor Kretschmar, or what I would like to call a week of celebrating him, his achievements. And now I would like to welcome you all to this final session of the symposium. My name is Dibul Nair, and I'll be your moderator for today's discussion for a short time, taking it from Professor Paul. Of all the things we know about Professor Kretschmar, we all will agree on his love for a healthy debate and a discussion. I vividly remember the first time I stood in his advanced software engineering class, and I said, Professor, I think Java is a dead language, and that's it. He was there lecturing me for almost 30 minutes about the importance of Java in the industry and the world. And trust me, I've never said these words except today. I hope you all share such discussion with him. It can be as complex as is deep learning the next big thing versus AI, or it can be as simple as is Messi or Ronaldo, right, as Professor Matteo said. Or I remember with Iman, it was the discussion on is tiramisu can be made without alcohol. You know, all these discussions can be, he will come join with this passion that you cannot even stand and debate, kind of it. To so honor his tradition of debating and discussion, it was apt for us to end this week by holding the symposium with a discussion. The topic we have chosen is also one of Professor Kretschmar's, one which he holds very close to his heart. The topic for discussion is robotics competitions and benchmarks, challenges and solutions. So now to discuss on the topic, we have with us a group of robotics experts from all over the world. We are joined online by Professor Daniela Nadi, Dr. Dirk Holz, Professor Nico Hochschwender, and here on site we have Professor Pedro Lima, and here on site we have Professor Paul Bluger, Professor Gerald Steinboyer, and Professor Matteo Mattiucci. Sorry if I am saying the names, pronouncing it wrongly, please. Close. So welcome everybody, and thank you for joining us today in this discussion. So let me go with the format of the discussion. What we have will give us a 2-minute time in the beginning to each speaker to talk about the different challenges and the current difficulties in robotics competition or robotics benchmarking, as you choose. And we go there, so this will be around 16 minutes. And then once this is there, then after that, we'll do a 5-minute open discussion. And after the open discussion, then we will go around with solutions, what you have in your mind. So 2-minute time to everyone to talk about their solutions, what they have. And finally, I would like to summarize on the topics we have discussed in there. So the order of the discussion, which I will do, is I will take it from the farthest from me and from there to me. So I think Dr. Holz is the one with the from USA. So I will start with him. And then this is a confusion. I think it's Professor Lima, and then Professor Nardi, and then Professor Hochschwender will also be there after that. And then from here, it will be Professor Steinbauer, Professor Mattiucci, and then finally Professor Pluger. Okay, saying this, I would like to wish that everyone would wear what we say Professor Kretschmer's shoes of discussion and debate, and try to debate here with the same zeal and passion which he does in this, and please give away your diplomatic positions you have. So let's start with our first guest, Dr. Dirk Holz.
Yeah, I think you're right about the distance, because it's also the time difference. Like while you have a nice evening in Germany, it's like 8:43 right now here. So given this time, let me first quickly say sorry for canceling my talk. When you're finding like goals and results I want to achieve, I usually tend to find like a sweet spot between being ambitious but also being realistic. And for this talk, it hasn't worked out, and I'm going to tell you why. And this is also going to be the challenge that I'm going to talk about. As most of you already know, like Gerhard had a huge impact on the RoboCup at Home League and on RoboCup as a whole, and many other robot competitions. So benchmark, like competitions as a benchmark was like his thing. And I wanted to dedicate the talk on Wednesday on the RoboCup at Home League and how it evolved over almost like 15 years. And in fact, like this year, like 2020 would have been the 15th edition. So let's see if that works out next year. Obviously, though, that's neither my own achievement, nor Gerhard's, nor anyone else's, right? So it has been a community effort. So I wanted to make the talk a community talk and basically give everyone involved a word and put that together. But yeah, this didn't work out. I just underestimated this involvement, but I can assure you we'll deliver it in the aftermath of this symposium. But that also quickly brings me to the challenge, because it is that very sweet spot between being ambitious and posing something which is realistic to solve. So I think the challenge for competitions at the benchmark is basically trying to find solutions to that multi-dimensional optimization problem, right? Where you want to have it scientifically challenging and relevant, but also it needs to be realistic, right? Like your participants in that competition need to be able to solve it. In the case of RoboCup, it's even more complicated because it needs to be interesting to watch, right? Like spectators, and not just like basically non-experts. And there are many more I can think of, and I'm pretty sure you are going to come up with many more. But like obviously, like results need to be statistically relevant, so you need to have enough trials. You need to make it interesting for participants, so you need to have enough opportunities to test their capabilities in the competition, but also to show off their latest and greatest research. And at the end, you just end up with like a very, very long list of things that you all need to have in that competition. So I guess that's more like my challenge. Like how is that done? Not just finding like a local minimum in that problem, but like finding the sweet spot that like perfectly aligns all these different dimensions.
Nice. Thank you, Dr. Holz. Now we'll move on to our next speaker, Professor Lima.
Hi again to everyone. I've seen most of you, and I've saluted the others. So yeah, let me go kind of directly to the point. I think that in this area of benchmarking for robotics and how competitions can help, there's a vast amount of things ahead of us, which is good in a sense, also not so good because it means there's a lot of hurdles that we don't know about yet, or others that we do and know are difficult. But essentially, the point is, and I must say that I went into this a lot, particularly because of Rockin and because of the discussions with Matteo and his team, Francesco Amigoni, and a lot with Gerard as well, and all the others like Daniele here. There's a lot of work in experimental science, which usually has to abide by several, let's call them rules. I mean, experiments have to be replicable. Somehow you have to be able to reproduce them in controlled scenarios where everything is very much similar to other places where you did it. And you have to, as Dirk just said, you have to be able to repeat experiments in order to have statistical significance. Somehow we managed to try to go through that in Rockin and in these European competitions, and have been discussing with Dirk, Luca, others, to try to do it also, particularly in RoboCup at home, by having test beds that are replicable all over, in this case, Europe. It's like a network of test beds. And I think this is the way to go. And I must say that to design these test beds well is a quite challenging thing. And this was one of the things that Gerard did quite well for the at home or domestic, whatever you want to call it, test bed, that now it's in 7 or 8 places, at least all over Europe, with similar specifications, so that when the robots go to one place, they face a similar scenario to when they go to another, and we can really kind of compare the different results these robots get in different places, because we want them to actually go to at least 2 of them. And so these challenges of having replicable robotics, I think they are the main ones we have now. Competitions definitely can help on that, but we have to do things which sometimes may clash with the popularity of the competition event. I see Dick's point, but I think in terms of research that is necessary somehow. We have to find a way in between. And also that we need to build test beds which can automatically more and more be able to assess the performance of the robots. We have done that with mocaps, motion capture systems, but more is needed. I don't know, like walls which have sensors that tell you when the robot bumped into them, other sensors that track people and the robot when they are interacting, all sorts of ideas like this. Things are the challenges ahead. I hope Matteo is not too angry that I've said many of the things I guess he was going to say. It's a pity that he doesn't have a mask anymore, because otherwise he would not be able to speak up too much against me.
I think you should thank me because I'm here in there. So next we have Professor Daniela Nadi in there.
Okay. In Gerard's style, I first disagree with because I think that the competitions have a big impact. You cannot measure the impact on publications only. And then I disagree with Pedro, because I think that, yes, test beds are fine. They may be good for replicable experiments, but I don't think that they can, can replace in any ways competition. A competition is a totally different story, and having benchmarks at competitions is the kind of question that I would ask now. And in fact, I see 2 challenges. One is, unfortunately, I can't disagree with Dirk yet. Just 2 minutes, I will come up with something. So the first challenge is really COVID-19. Because it's been, if I look at my team, it's been really disruptive. This year, there was basically no activity, and while we can see a model of a new model for conferences and other scientific events, it's very, very difficult for me to, imagine a model for competition that is at the same time attractive for the students, good for benchmarking, and a large gathering of people. And that's well, of course, we really hope to get through this COVID-19, but COVID-19 will change things in one way or another, and we have to understand why. And the second thing, maybe I will speak more in my other 2 minutes, is that we are going towards collaborative robotics, meaning that humans and robots should interact a lot. Now, this is completely missing in the competitions, especially missing with respect to the general public. Now we have made an experiment in Milton Keynes with this competition in the smart city, where for the first time we had really visitors of the competitions that were testing the human-robot interaction. I'm finished the 2 minutes, so I will leave this as a challenge, and maybe we have some answers here.
Thank you, Professor Nodri. Now we will move towards our own from Germany, Professor Hochschwender.
Yeah, hello everyone. In Gerhard's style, I partially disagree with Daniele Nardi, and I agree with Pedro Lima, because in the
Sorry,
times
that's not
of
Gerhard's style.
No, but in Corona times, actually having these certified test beds actually, I think, will help to overcome the Corona dilemma, because with having the certified test beds locally, at least, we can still carry out competitions, smaller competitions, maybe local competitions, and can actually still obey the Corona rules by having maybe smaller events. And that would not be possible if we would not have the certified benchmarks or the certified test beds. And concerning the challenges, so I see two actually benchmarking challenges, not talking about how we would realize them in the context of competition. The first one is everything related to long-term autonomy. So what is the take of having robots really operating over a long period of time, and how can we actually compare different systems, because that is a different style of, that would be a different style of experiment, yeah? Because we would have different kind of measurements over a long period of time, and I think that is has not been done. I mean, we have seen it in different competitions to do some repetitions, different runs maybe. We have done this, for example, in RoboCup at work, that we have the same kind of task repeating several times, but this is different to a long-term scenario. And the second challenge I see, and that goes a bit into the direction what Daniele Nardi also mentioned, is all the aspects related to collaboration. Yeah? And there, particularly right now, we very much focus the functional properties of systems, and in the task or in the purely functional benchmark. Yeah? But we also need to consider more non-functional properties of the robotic systems, in particular things like, say, in reliability, and how to frame that into an interesting competition challenge, I think remains open.
Thank you, Professor Hochschwender. So this, we will start with our on-presence speakers. So to start with Professor Steinboyer.
Yeah, I have to commit I'm not a part of this benchmarking gang, so I'm a little bit an outsider. And I'm not a full expert in that, but I want to mention a few things. First of all, and I agree the passion with Gerhard for RoboCup, but after 20 years, I'm not sure anymore if benchmarking is really done in RoboCup. Yeah? Because at the end of the day, I always ask myself why teams won, and we all know to some extent it's hacking, or good hacking. On the other hand, I also ask myself, if not anyway, good researchers go there and they would be anyway successful, yeah? And then they won the team or the competition. About the rocking stuff, and I went through the literature because I wrote, we tried to set up a research proposal. That's why I agreed very much what Matteo presented there. But I think we need to extend this whole story. And there's a lot of work going on in software engineering with testing, right? So you automatically generate test cases. And that would also mean automatically that I generate new environments. So in that competitions, we always stay in the same competition environment, basically, and just switch a little bit around. This would, in my opinion, be a good step forward. And there's also, I think, in the engineering idea of Gerhard. But on the other hand, this would also mean that we need metrics, how difficult is an environment. And there is work going on. On the other hand, we are also connected in my university a lot with people who are doing testing, automatic testing, but also verification. And we also have a strong connection to the people nearby from psychology. And they test completely different, right? They have item generation, they have very good theories and methodologies to make tests really valid. And what they also can do, and that would also be nice, and that is connected to what I said before, is they can do adaptive testing, right? So you start with a middle hard environment. If the robot fails, you go down. If it goes up, you can give it more difficult, and then you can have a much more detailed environment or assessment of the robot.
Thank you, Professor Steinbauer. Now I would like to go with Professor Matthiocci.
Yeah, so I will disagree as well with Pedro, but just because, I mean, it's obvious. But I would like to start from what Gerald already said about a more systematic way of testing or verifying systems. And I think that this poses an interesting question, which is, are competition the right way to perform a more systematic testing? When I say systematic, means to span in a controlled way all the possible variables and conditions that might challenge or that might be observed by a robot. And in this case, I think that I don't have an answer. We have seen, or we are looking at the idea of testbed, the diffuse testbed, whether they can be used as a way of varying the parameters. So in a sense, I think that the idea of a diffuse testbed and the fact that we are testing systems on slightly different implementations might be a way of varying the condition, and might be a way to observing the robot dealing with different environment. Indeed, especially when you have a home-like environment, it ends up that no single testbed is similar to the other one, because no single house is similar to another one. And that was actually one of the push of Gerhard, trying to frame and define what are the classical or not classical element that should appear in a, let's say, RoboCup or at home or rocking testbed. I remember one of the cool things he wanted all the time was the patio. I don't know why. I still haven't understand why in the reference testbed there is a patio outside the house. Unfortunately, we didn't make it yet, but we never know. But I think that this systematic approach, and here it comes the challenge, is something that it's missing in competitions. And the question that I would like to ask is whether whether competitions are the right place to do this systematic evaluation or not. I will take an example. Right now, there is an ongoing benchmarking project which is called Eurobench, which is very focused on humanoids and exoskeleton, or let's say human helpers locomotion. And it's only testing them. It's building a facility with several, let's say, exercises for humanoids or for exoskeletons, with the idea of testing very specific functionalities. That's one possible solution. Unfortunately, it doesn't solve the problem of complex tasks, where you have multiple in components, including human-robot interaction in the play. And I think that still competition might not be the best solution, but is the best we have so far. That's my view.
Thank you, Professor. And finally, Professor Paul Pugel.
Yeah, this is very difficult, yeah, because I mean, I intended to start as the devil's advocate, again, remembering someone, yeah, being a devil's advocate. But of course, now this is very difficult because there were so many reasonable statements were made already. I mean, it's difficult to agree to everyone, right? So maybe just I have two provocative things, and then I sort of give in on the arguments which were presented already. So the first thing would be, let's say, if our community would be wholeheartedly committed to benchmarking, or saying, yes, we say benchmarking is essential, where is the MNIST of robotics? Yeah, so MNIST was one of the key success factors for pattern recognition, deep learning, whatever. I mean, whenever you have sort of an algorithm which you like to test, you sort of grab out the MNIST and compare it to the current best result in the field and say, hooray, I'm a bit better. So if it is really so necessary, why don't we have it? Yeah? So, okay, so this is number one. Number two would be, it's all wrong, of course, what we are doing, because we have to align to car industries. So how is car industry doing this these days? So how do they make their systems robust or something? How do they get their systems even certified? I mean, it's not just making them robust. There's a certification going on. And there are two ways how they do it. They do it on micro level, so they do it very small scaled, like they do driving in circles and look for this part of the circle, if this is adhering to some criteria, and from this microscopic thing, they actually build something like, by composing parts, they build something like a full car dynamics model, and this can be then, in fact, certified. This is one end. And then, which is sort of closed loop, yeah, because still you look for the driver, which might be the robot, by the way, doing the right thing. And on the other scale, they do it very large sized, like they have petabytes of American highways where automated cars are sort of driving on these highways, and they use this, of course, obviously completely boring and superfluous data to validate the algorithms based on this huge amount of data, and then saying after a while, okay, this sort of complies to the regulations which we have. So these are sort of two semi-provocative things. We are doing it wrong. But of course, there were many right points already mentioned. So for example, Pedro, you mentioned statistics. Also, you mentioned actually statistics. Statistics is missing. So there is I mean, if we do recognize benchmarking is a good thing to do, we need to have statistics, reliability, enhancing robustness, repeatability of experiments, because only if we do it really sort of repetitively, we could get the grasp and the hold on this sort of system doing that things which we want and validate. I mean, yeah, it is. I mean, statistically significantly improvement in whatever you want. And then, of course, and I think this was mentioned also by Gerald, competitions are the wrong way. Why are the competitions the wrong way? Because of this robustness. Yeah, unfortunately, the competitions are coming back to Dirk, they are very attractive to the audience. They have to be attractive to the audience. So they have to be this aleatoric impact. Yeah, so like a soccer game is simply not reproducible. It's a one-time issue. And as it is a one-time issue, it may have surprises in its outcome. But on the other hand, for serving the purpose of benchmarking, this is simply not computing, because benchmarking would say we enhance on robustness. Yeah? We would like to make it really good and sort of provably better. We advance the level from where we have been before to the next level, actually. And for that, unfortunately, the tournaments having this random aspect in some way or another, also the time pressure aspect which you mentioned, so like hacking away instead of doing decent research, of course they are biting here and they are in the way to make it really sound.
Thank you, Professor. I think now this sets, the floor is open now if anyone wants to disagree. I think that's the proper way.
I would like to play the reminder of Gerhard. So I think the first thing that my father would always say is competition is important, because we of course need a healthy a healthy driver to innovation and to make students not hack. The professors and the supervisors are there, right? So it's actually also their job to ensure that not only hacking is possible. The other thing I wanted to mention is I would like to disagree that COVID-19 is purely a challenge, because I want to say that it's also hello.
Hello.
So COVID-19 is also a big opportunity, an opportunity to bring robotics to interesting new fields. Take, for instance, chemistry or physics, where you have a laboratory, where you have to do certain tasks, oftentimes 100, 200 times the same task, and you would like to do, you would like to automate this. But every of these tasks has to be remodeled every time you do a new experiment. So there is also the opportunity now in times where researchers cannot access the lab anymore to go there and say robotics could be benchmarking on human robotic interaction by placing a robot next to the researcher. The researcher then shows basically the robot what is to do, and then the robot tries to work on this, and the researcher is on its own. So I think there are interesting new things you can do, and if you work together with your colleagues from different fields, this pandemic might be actually in the end an enhancer of the ideas that were discussed already. And yeah, thank you for my
nice. Thank you, Thomas. And finally, we have Professor Manuela Velosa also joining us. So, as we just to brief you, in here we were discussing about the challenges currently in robotics competition and benchmarking. So maybe you can also have your opening remarks on the challenges we are facing in competitions.
Yeah, that's very nice. So basically, I think competitions are an opportunity to bring people together. I think the challenge of competitions that I actually would like to raise is the fact that it, as in RoboCup, they should be continuous. I mean, a once in a lifetime competition does not provide the same contribution or the same impact as the fact that we repeat them every year. For example, think about the DARPA competition, Urban Challenge, all of those happen once and then nothing else happens after. And here, this is the good thing of RoboCup that we have learned was this consistency and going like, hi Iris, hi Thomas, and going like every year and changing. And I think that in some sense, Gerard was very influential in terms of like always every year moving one step forward. So competitions without this kind of like continuity, maybe we don't need to be 20 years like RoboCup, but at least target like 5 years competitions. And Thomas, like you were saying, it's, I mean, competitions are good, but the one-shot thing is not very good, I think. So that's my thoughts on competitions. And I don't have these concerns about people saying everybody wants to win. Of course, that's a competition. Everybody wants to win. It's part of the competition. And the interesting thing is for people to feel that they can share how they won, what made them like win, and definitely share those advances. So the aspect of competitions is the continuity, and also, I mean, like the increase in complexity, and also the sharing of solutions. We don't compete for the sake of being adversarials, but we are all pushing forward the same sciences. So there is that about competitions and sharing, and for the year after, people starting at a different level. And that's very nice.
Thank
I do have to, the Joan Fadel thought, competitions can also have some like nice aspect, like in junior, I remember always how Gerard liked also the dance, you know, though he loved the soccer competition.
Yeah.
There was his RoboCup, the junior dance, and I sat with him, sat next to him several times watching this, And we really loved it, what the kids were doing. So competitions also brings a lot in terms of creativity. And so I'm sure we all experience these, but Gerard really loved these, seeing the kids with the robots and the kids like dancing at the same time as the robots. So that was something that he truly enjoyed. The others were more stressed, are they going to win or not?
Yeah.
But the RoboCup junior competition dance was very enjoyable for all of us and for Gerard also in particular.
Thank you, Professor. I think the floor is open. If anyone wants to counter any other, please use the floor. So anyone wants to go first?
I offer to go first.
Okay.
Okay, I want to take over the suggestion of Paul of comparing with the car industry. I think that the RoboCup is the formula, or the robot competitions are the Formula One for cars, while they should not be confused with the testing facilities in the car companies. These are two different things. Still, you want to benchmark the performance of the cars in Formula One. So this is how I see the thing. There is, and of course, whatever you discover in RoboCup and through this benchmarking, this can be transferred down to the industry.
Yep. Thank you.
I also wanted to pick up on something that Paul said. At some point, he asked rightfully so that why don't, if we need these kind of things like benchmarking, why don't we have it in robotics? Maybe because it's not needed, he kind of added up provocatively. I think it's basically because it is difficult, because we are still a little bit like in the infancy, and there's a lot of things being done which are quite interesting. I mean, people, and I hope we keep doing it, people are excited about having this robot that works, and it's the first thought is not to benchmark it. I mean, it's kind of exciting. Look, man, oh, hands, my robot works and does a lot of great things. But I think that at some point, we also have to move beyond that. And the reason why people have been doing this for what we call, like Matteo said, the functionalities, has been doing a lot of that for pattern recognition, images and other stuff, is because it is relatively simpler to kind of set up these benchmarking experiments. While for the whole system, how to compare different things is much more difficult. I'll get to that in the next part of the discussion. And in fact, with competitions, I feel it's a little bit the same. Of course, the first thing is to make them attractive and to sheer at the game and so on. But I think we can find, and we are finding ways of also making it repeatable without being too boring, replicable, and so on. As for the soccer game, I mean, you can just play between the two teams for several times and you will have already an idea of how the two perform relatively. You will have some statistics, let's say.
Thank you.
Building up on your example.
Yeah.
This discussion is too technical for me. I wish we would talk more about Gerard than the competition. I really don't, whatever. Go ahead with competition.
Nice.
Anyway.
So I think I'll close on the open discussion now, and then I would like to, what I would say is the closing remarks from everyone. What I want from you is, what is the future now? So what do you think we should do as a community? And in this effort, in remembering Gerhard Kretschmar, what should we do in this next years in the robotics community, in the competition and in benchmark? I would like to go in the reverse direction this time.
Yeah.
So.
Okay, I mean, this is very much in the spirit of Gerhard, I think, joint forces. Yeah. So, I mean, we have to sort of course, take, let's say, really dedicated statements or dedicated approaches or something like hypotheses, how we could attack potentially the problem. And then, I mean, this is a big strength of this community, I have to say. Okay, we might have hard and harsh arguments, but on the long run, of course, it turns out to be converging to something, right? Yeah. And so if our insight, I mean, I appreciated your talk very much. I think it was very nice because it sort of really wrapped the things together and say, yeah, there is a need for it. You even came up with this matrix design where we are actually small things which you can test all in splendid isolation, so tick mark them and so on. So I think this is actually, there is a methodology already laying around. It's open, yeah, there it is. I mean, we could really hop on it and try to sort of establish it and make it a reality. And coming back also to Manuela, I mean, the statistics aspect, yeah, okay, we need statistics to make it replicable. But now assume, coming back to what is the interpretation of this, assume Bayern München is playing, I don't know who, Sevilla yesterday evening, now 20 times. Would it be fun? Of course it wouldn't be fun. I mean, although statistically speaking, that we would know that on average they are 55% of all games they are winning. Yeah, okay, fine. But I mean, of course, the community is after the single match, right? I mean, you want to have this sort of thing going on, this competition going on, and that's over, and you long for the next one. Yeah. So actually, there are two aspects we have to address and face. One aspect is benchmark is needed to get the science sort of really pushed up and working, and the other aspect is still we have to have an entertainment thing in here to make this thing attractive to a wider audience.
Thank you.
Okay, let me add again that somehow it's all true, but if you don't have charismatic people being part of the competition, and if these competitions are just with like boring people, ruling people, and so forth, they die off by themselves. There is in competitions, be it like the coaches of the teams or the organizers, there is a need for charisma. There is a need for people to feel good when they come to the competition. Otherwise, if it's like painful and if like, okay, you don't like to participate, you just don't come just for the sake of the science. So I think that there is a human component that we cannot forget. It's not something we write on papers, it's not something we write on a proposal, but when we choose the leaders for these competitions, I think that my advice is to take into account the personal aspect.
Right.
Also.
Right. Thank you. So, Matteo.
I will start from this, actually, and I will point out one thing that I really appreciate is that at the end, we are all joined by this RoboCup experience.
Yeah.
I mean,
Matteo.
ciao, Manuela. Nice to see you. Okay, so we met together, and we ended up, as you see, to become friends. I mean, very close friends. And I think that this doesn't happen so often in science. And I think that that's one thing that we should put forward, and we should aim for the future. I mean, competition, yes, are about winning, but I must admit we never won. But I'm still here.
Shame on you.
Still here.
We got second.
Keep trying, Matteo. Keep trying.
Yeah. So I think that what we are seeing here is the spirit. And I think that my wish for the future is that in everything that we do, beside the love for science, that's what drives us, the curiosity. I mean, we are all curiosity-driven people. Otherwise, we would have not been here today. We also do this, very friendship research. Is part of the sharing, but is sharing life more than just the science. And I think that I will push this forward, and what we should do is to enlarge the community. I think that RoboCup is a big community, but with respect to the robotics community, is a sort of niche. It's a very special niche. Is a niche of friends. I mean, we should spread this message, which probably didn't reach all the other researchers. I mean, all of us. I mean, we started RoboCup at the same time with Gerald as well. So, I mean, that's what I like about that, people.
Thank you, Matteo. Professor.
So, to say something positive, I'm not thinking that competitions are completely useless. Yeah? To hooking up with Manuela, and she's together with Gerhard, I guess, a good example. What we need is, of course, we have to have educators that really motivate people, that good people come into RoboCup. Yeah? And that's exactly what we need. And that is, of course, we have here the best AI and robotics researchers here, right? So and Gerhard was remarkable also already for the youngsters, right, to get people in. And we already have stories. Yeah, people started 15 years ago as kids. They're becoming now professor, and they have done their whole career somehow in RoboCup Junior and the RoboCup. So that's really nice to see, and that's the spirit. From the other side is what I would recommend is what we've sometimes suffer from is not to invent it here problem in robotics. There is aerospace, there is automotive industry, and they're doing really cool things. Of course, AI is a little bit more complex than a regular car, that's admitted, but we should really look to the side, and in particular also to other science, as I said, psychology. They're making very nice test designs and so on. We can look there, and we need attract more of these people coming in. And here again, to see when you go, for example, to somebody who is not in robotics, and you show him they're in RoboCup, and that's the test case, then you even can get a physics guy or psychologist or whatever. So that's the nice thing here.
Thank you, Professor. Now we go to our online Professor Hochschwender. Please, your final comments.
Yeah, so what Manuela already said, I think that's the basis. The people are the basis, yeah, and this is really the strengths, yeah. So Gerald, I'm also one of the examples, yeah, making as a student, as an undergrad student, and a master student, and a PhD student, all my time also in RoboCup, and finally entered a professorship. And I think these are the examples where we can really build on, yeah, from senior to junior and so on. And I mean, this is also so motivating that this is a unique selling point of the competitions, yeah. When you see the kids, when you see the students, that something is working, and also the social aspect, yeah, is so important. Working together as a team on a common goal. This is a skill, regardless of programming skills, mathematical skills. This is the social skill which is so relevant for innovation and for creativity. And we should. My take here is, yeah, continue and broaden it and really focus on this social aspects, yeah, and that is really a unique selling point, and you can see it also in teams that yeah, strong students then support weaker students, and then after spending the nights on the competition, they succeed in finishing their piece of software. And this is so rewarding, yeah, that we should spread this that information more to the public, and saying this is the unique thing. Whether you win or not, but everyone achieves something on the competition, and yeah, we should. That is the thing which makes it unique.
Thank you, Professor. Now, Professor Nadi.
Okay, very quick. I'm going back to the challenge that I launched earlier, which is involving the visitors in the competition. So Manuela's made a different statement for the 2050 goal, which is that there should be cooperation between robots and people. And still, we don't have any possibility of involving people, visitors in the competition. I understand it's a difficult thing. We have done a trial in Milton Keynes of doing this. And I know also the difficulties, but I think this is an important aspect that would also make robots much more acceptable. And, you know, it's food for thought. We need to find out good ways of doing this. I take this opportunity to say goodbye to everyone. I really have to rush and to go out. Anna is pulling me, my arm. So I would stay much longer, but you know, it's been a great, great pleasure to see you all.
Yeah.
Ciao, ciao.
Ciao. Thank you,
To
Professor.
see you, Daniel.
And finally, Professor, before finally, Professor Lima.
Not final.
No, not final.
Yeah, I'll pick into what Matteo said a little bit ago, which I thought was very nice. I think that what distinguishes this group of people and many of the people in RoboCup when you think of the community of researchers and educators, is that besides being colleagues, many of us are also friends. And I think it has to do, I mean, it's cause and consequence. It has really to do with the way the competitions go. Nico just said it. I mean, this great stress of the team working together overnight and knowing each other much better. And this is really something that only those who were there know what exactly means. And so maybe this also creates bonds. And I think that's one of the reasons. And in that sense, I think RoboCup is a niche, yes, but it's like a big niche, and it's not so bad, because if we made it much larger, it probably would have to be with people who don't like so much the spirit and maybe would not work. On the other hand, and picking on this, maybe we could try to spread this message to the world in the sense of looking at the future, which is the purpose now here. I mean, we have been even discussing this in some workshops associated with this European project we talked about today, which would be to try to bring kind of a revolution to robotics conferences, in the sense of having parts of it which are not just the traditional paper presentation, but also like small competitions, not in the style of what they are now, because they are more like shows to attract people to the conference, but really sessions where several different researchers and teams present their solution or their approach to a problem that was presented, say, by industry or just out of the blue as an interesting problem. And I think this could be kind of a small revolution that would bring also to these other people who are the non-believers the relevance and impact of competitions in research and education. So that's what I wanted to say.
Thank you, Rosa, and Dirk, Dr. Dirk.
Sure. And hi, Manuela. I read the message, but thought I'd just continue listening. I wanted to pick up a point that Manuela just made, and that is, I think regardless of whether it's like a competition or it's like a benchmark or it's like shared common test beds for doing benchmarking, I think the key to success is really like not doing it once or twice, but doing it as we do in like RoboCup for like, I don't know, almost 25 years now. I guess this year would have been the 25th. So I think the key to success is really doing it every single year. And then basically to like really drive the evolution of that league, right? Like to closely monitor the achievements of the participants, to look at whatever results you can get out of that, whether it is statistically relevant or not. Hopefully it is. But basically driving the league in the direction you want to have it go, right? Like we see what doesn't work, so we change it. We see what has been solved, so we make it more challenging. We also see what has not been solved, so we make it more valuable in terms of like scoring, for example, to make participants solve it. And last but not least, like I agree with basically all of you, and that may be very Gerhard untypical. It's really like this whole community effort. Like you just need to have everyone involved here. You like without that community, right? You don't have any contributors to any single aspect of your competition. You don't have any participants, and you don't have anyone who is interested in that. So you really need to kind of like build up that, that great community.
Nice, thank you. Professor Velosa, would you also like to join, or we could final word? Final word.
I think I said most of the.
Okay. Okay, so I would like to conclude and have a summarization of this, but the topics are so huge and so many ideas have been discussed in here. It's a bit of a difficult task, but I will try my level best. So the challenges which are there is in competitions are also being watched by people, so it has to be interesting to people. It has to be statistically relevant. Then the other one are designing test beds. To do this is a complex task. Then there is what told by Professor Nardi was the challenge of COVID-19 has created new challenges. So to do robotics competitions in the future to come. So this, I think, is a very important point. Then by Professor Hochschwender was what about long-term autonomy? Competitions are smaller, 1 day, 1 week event. What about long-term autonomy? How do we challenge this? And how do we find about collaborative robotics? Also, there is competitions. There was a statement of competitions don't benchmark, right? So by Professor Steinbauer, and the metrics required, and where are the other industry people who do their continuous testing in software engineering in different fields? How can we bring them in? So that's another challenge. And by Professor Lima about systematic testing missing in competition. So that's one thing very much missing. And Professor Paul giving where is the MNIST of robotics, right? So where is it? We should have such things in there, and benchmarking missing robustness. So the benchmarking is required, robustness is required in benchmarking, and this is what is the challenges. And to talk about the solutions which have been discussed, it's all about first the joint forces. We should bring the community more together. And to build, we need a charismatic leader to lead this process in a forward way, to enlarge the community, to go from RoboCup to the bigger robotics community, and then to the other testing and the software engineering and the psychology to bring them in this bigger community, learn from other industry. And the one thing which everyone agreed, competitions are required because they bring people together. So more than the science of it, it becomes the social skills which makes them, which it improves on it. And I think everyone on here will agree on the competition part which is required for it. So with that, I would like to summarize, and I would like to thank each of our speakers who are joining us from Zoom, and also who are joining it in person. So for everyone in here, we have built this special relationship, and Professor Kretschmar was our binding element, and he introduced you all to us in here, Hochschule. And because of these times, we could not travel, but we would always like to have this relationship with you all people, and when times are good and when there is a healthy environment, do visit us to what we call home away for Professor Kretschmar in here. Bye-bye from here. Bye. Thank you, everyone.
And thanks for the great organization.
Thank you.
Welcome.
Yeah,
Pleasure.
welcome. Yeah.
Thanks for having us.
Thank you.
You are always welcome.
Yeah. Okay, so